Yes, I just started the recording.
So what we'll do is, as timekeeper, I'll have you start the recording for the first session. And then basically we will, the last timekeeper, Omid, will turn it off at 2 o'clock. So all you have to do is start it when you get ready, which is usually about a minute until the session starts. And that's it. And then you're there for help with technical difficulties.
Yeah. I think the recordings are already started. So.
It is. Perfect.
Melissa, everything going well there?
Yes, Pinar just got all of her slides loaded. Again, our normal Teams confusion, just for temporarily. And she's up and she's good to go. Sugan's got the recording started, so whenever y'all are ready.
Awesome.
All right, I'm going to go work on some faculty contributions, but I will be monitoring the room. So,
okay.
And I got to see Ernan's baby. Oh my goodness, how cute is he? Thank you, Hernan, for that. I appreciate it. I love to see the little babies.
We'll come by in person. And
yes. Yes. Thank you.
I didn't get to see him, Hernan.
Yeah, well, now it's conference. We'll have to Zoom separately.
Okay. Sounds good.
Here we go. So now I stopped sharing, right? Okay. And nothing is showing up for me? I missed the days when
you know, Matt, why don't you do this? Why don't you send the files if you haven't already to Raja?
I haven't. Yeah.
Okay, so then he can share the screen, and then you can request control on the top.
Pinar, whenever you're ready, you can start.
Okay, I can just go ahead and get started. All right,
yes,
great. Great, let's do that then. Good morning, everyone. Hopefully everyone is great, doing well. Thank you to the organizers for giving us the chance to present this new paper. It's actually the first time I'm presenting, so hopefully all will go well. This is going to be joint work with 3 co-authors, Ricardo Perez-Truglia from UC Berkeley, Maria Petrova from a number of institutions, including Barcelona and New Economic School in Russia, in Moscow, and Andrei Simonov, who's at Michigan State and RENEPA. So the topic of this paper is trying to understand the motivations with which people donate to different accounts. And in general, we have an existing and ongoing puzzle in the economic literature, but trying to understand the motivations of political giving. And this paper will try to shed light onto this using a number of different methods, a number of different data sources. If you have questions throughout the presentation, please, I cannot see you. I'm also very unfamiliar with Microsoft Teams. Hopefully, keeping fingers crossed, no technical issues. But please do feel free to jump in at any time if you have questions, or my timekeeper, Sugan, hopefully will tell me that there are questions. So let's dive in. What is it that we are generally interested in this talk? We want to understand, as I mentioned, the motivations for giving. And giving, if you look at the overall percentage GDP terms, it's actually not small. Just the charitable giving in the United States comprises about 2%, according to some accounts. And in general, when, in marketing literature or in economics literature, we have a lot of works that are trying to understand the motivations for charitable giving. I think charitable giving and what drives it has been well understood, but much less so for political giving. And in specific, we don't really have works that try to understand how these two accounts of giving move together or affect each other. The only one work that I'm familiar with that I could see that or knowledge exists in the economic literature is actually a paper by Yildirim. And in this paper, he claims that these two amounts of accounts of giving are complements, that if you give to politics, you're also likely to give to charity. So we are interested in understanding if there are any common drivers, common rationale behind giving to these accounts, and in general, again, try to understand this puzzle for why people give to political campaigns. And let me try to explain why this seems like a puzzle. So when you look at charitable giving, people could be giving to others. This self-regarding, other-regarding preferences could exist for a number of reasons, such as pure or improved forms of altruism. I might be giving because I simply want the betterment of them. I want their welfare to be improved. Or I might be giving because I want to feel good about myself. This is the warm glove explanation, that I simply want to feel better because I help others, or I get some kind of I'm in the good light, I get some kind of a benefit in terms of how people view me. Drivers of political giving is not as clear. In fact, if you look at the donations, okay, what happened here? All right, we're gonna go through an entire set of, unless Sugan, you can take me to back to the beginning of my slides. My apologies. This is regarding not being very familiar and not having control right now. Sugan actually has the control of the slides as opposed to me, not having enough experience with Microsoft Teams. So going back to drivers of political giving is not as clear, because if you look at actually the donations that exist in the political space, a significant portion of them are coming from small donors. About 40%, according to some accounts, is actually small donors. These are $15, $25 donations that are coming from ordinary individuals. And that amount is way too small to really have any kind of impact on any kind of political activity or political policy. Some argue that there might be some instrumental motives, such as trying to influence the policy outcomes of politicians. Others argue that this is simply an expressive political participation and the consumption that is related to my desire to participate in politics. But ultimately, why do people give $25 to a politician? That's still a puzzle. We don't understand why there's, in some sense, so much money in politics that are in small amount. At the same time, we don't understand why there isn't enough of it. If this is something that people get some kind of consumption value, why don't we have more? So we would like to see if political and charitable donations might be satisfying the same needs. I'm worried now of pressing any button. And if so, how one might be impacting the other. That's what we are going to focus on. In general, these are the research questions, as I mentioned, so let me actually dive in. We will try to provide some information that is also proof of concept. If we can understand how one account of giving can affect the other one, we can use that to be able to make inferences about, for instance, policy changes. What happens if there's a cap that's added to politics? political donations, which happens quite often? Or what happens if there's some kind of a disaster that's happening, right? How is that going to impact potentially political giving, and how that in turn can impact the political outcome? So we are going to focus on these type of mechanisms, which we can try to identify also and do so in the paper. Okay, in general, what are we going to find, in case you need to leave out in 10 minutes? What we find are that these two accounts are, unlike what the literature suggests, are actually substitutes. And our explanation, or preferred explanation, for why these two act as substitutes is a warm glove motive. It's, of course, not going to be related to altruism, perhaps not so surprisingly. We will find a crowd out of charitable giving if we were to just focus on how much political donations crowd out charitable giving, or how much charitable giving crowds out political giving. So that's going to be a factor of about 0.26. We will also see that caps on political giving will have implications for voting outcomes. In specific, if we were to focus on incumbency advantage, we'll see that more money in politics might be helping the challengers, or put it differently, if there are disasters that are happening resulting in less money less money in politics, that might actually help the incumbents. Okay, so let's go in and try to understand how we get that. In the paper, we actually do a bunch of different things in the revised version of the paper, which was not the posted version. So what I'm going to focus on in the next couple minutes is actually going to be some empirical observations that are coming from various charitable organizations, primarily American Red Cross. We'll try to isolate information shocks which might influence giving to politics or charity. So in general, if you wanted to answer a question like this, whether these two accounts of giving are substitutes or complements, what you would want ideally is some kind of an experiment where you can shock giving to just charity, and then see how that potentially affects the donations to charity as well as donations to politics. And ideally, you would want to replicate this experiment where you would want to have some kind of shock to the price of giving to politics, and see how that actually affects the donations to politics versus the donations to charity. Right? In an ideal world, we would want to do some kind of an experiment like this. Doing this type of an experiment is not straightforward, is not possible. There are many reasons for why giving to politics might be very much related to giving to charity. So what we are going to try to take advantage of here are going to be essentially two things. We'll focus on, in terms of shocks to charitable giving, the need to charitable giving, we will think of foreign natural disasters that come in, that take place outside of the United States, which provide some reminder to the consumers about the need for charitable giving, and we'll see how that affects charitable giving to American Red Cross, as well as the donations to political candidates. And then we'll do some sort of a replication, a reverse of the political shock. We'll do a DMA boundary strategy, which is by now well used in marketing. We'll look at DMA boundaries, counties that are paired on DMA boundaries, designated market area boundaries. We'll compare how much additional political advertising in one DMA compared to the paired DMA, in one county compared to the paired county on the other side of the DMA, shifts the political giving as well as charitable giving. So that's what I'm going to do in the next couple slides. So let's go into that. Let's focus on first the charitable contributions. What we have as data is data from American Red Cross. We can observe at the individual level of giving. This is anonymized. The donations that people make between the period of 2006 to 2011, we can see at the zip code level, we can see the date and the amount of donation. We can also observe, this is something important, we can also observe the charitable appeals that American Red Cross is sending to these individuals. So we can see how much effort American Red Cross is exerting in order to be able to collect money from individuals. American Red Cross, I'm sure everyone is more or less familiar, but this is a humanitarian organization that's really focused on disaster relief. And this is something important for us as well. Ideally, in order to be able to understand the degree of substitution between charitable and political giving, we would like to take advantage of exogenous shock, right? These exogenous shocks that potentially arrive and change the price of giving to one account versus the other. For any charitable organization that you can think of, finding such shocks is not always straightforward. If you think of, for instance, cancer, if you think of, for instance, organizations that are fighting poverty. Finding potentially repeatable and exogenous shocks is not straightforward. What are the drivers of giving to cancer? Are there events that are happening that that do not affect giving or the ability to give to a charitable organization, but somehow allow individuals to give more? The reason why we can focus and we think American Red Cross is actually a good testing ground is precisely this: the fact that there are foreign disasters that happen that do not affect the ability to give to American Red Cross in the United States, but still get plenty of media coverage, still gets act as reminders to individuals of the need and importance of giving to charitable organizations. So we like the idea of being able to take advantage of this well-known, somehow respected and trusted organization that also gives us the opportunity to test this. The political contributions that I'm going to focus on, political data, donation data is open or can be obtained from Federal Elections Commission. You can observe for each individual donor the name, address, and date of donation. There's a caveat here though. By regulation, political campaigns are only required to report donations that are overall in a year of $200 and above. They do report, however, less than 200, but this is not required. So there's some missingness in the data for less than $200, but we will try to deal with that. In the extensions, this is donations from individuals to political candidates, but in the extensions, we also consider donations to political action committees in case that's something that you're wondering, and we'll see that the results can be, with some caveats, extended to political action committee donations too. So what do we do as far as empirical specification? So this is going to be, again, the disaster information shocks. What we are thinking on the left-hand side is the total contributions to either American Red Cross or to political candidates from count to C in a particular week T. On the right-hand side, I'm going to do something that is more and more common in economics, but fairly, I think, less done so in marketing. I'm going to have a dummy that accounts for, that basically turns on a disaster post period. That's going to be the dummy IT plus 0 to 6 weeks. That takes the value of 1 for the 6 weeks period after a disaster happens. Now, I'll tell you what a disaster is, and I'll tell you why we focus on 6 weeks, because there's actual literature, sufficient literature that shows that most charitable donations after a disaster are concentrated in the 6 weeks after the disaster period. We don't want too short of a period because it might, especially let's say there's a disaster that happens in Japan, might take a few days before even in Japan you can understand the true magnitude of the disaster, and it might take another couple of days for that information to make it to United States, and it might take another couple of days for people to realize and remember and feel bad and send something in the mail and that to be received by the American Red Cross. So we don't want this to be too short. At the same time, we don't want this to be too long, of course, to be able to make a causal inference. On top of that, I have, as you can see, 2 other dummies. So the one dummy is going to be this -2 to -1 dummy. That simply is telling us to 1 to 2 weeks before period of the disaster. This is essentially a falsification check. Right? If this is turning on somehow, maybe the disasters are not arriving randomly, and that would be a concern. At the same time, the other dummy is a post-period dummy. Ideally, this is measuring if there's some kind of an intertemporal substitution that's happening in the future, or if this is also for us a sanity check to see if the disaster donations are indeed concentrated in the 6 weeks after the disaster takes place. Now, for foreign natural disasters, we are going to focus on disasters that are in the form of earthquakes, floods, storms, and so on. This can be obtained from an international database called MDAT. We focus on disasters that are fairly large in size, that is corresponding to 300 plus deaths. That increases the chances that it's going to be covered in media and that it's going to actually make people feel bad that they want to donate. But we have actually done a bunch of robustness exercises around this definition, and it seems like the results are fairly robust. We, of course, add a bunch of different controls and a bunch of different fixed effects to make sure that these results are not spurious. Now, what are we finding? Let's go into findings. And again, great that we have a wonderful, okay, all right, here we are. So when we look at the responses to the events that are happening, In the first three columns, you see how the charitable contributions to American Red Cross change as these disasters take place. And on the right-hand side, with the columns 4 to 6, you see how political contributions change. Focusing on the first column, you can see that indeed in the 6 weeks post a disaster taking place, the donations to American Red Cross go up by about 28%. That magnitude it's fairly stable across the 3 columns, where we start adding the falsification check as well as the ex post donation check. You can see that the falsification dummy essentially is insignificant. That doesn't seem to really turn on, and that's good news for us. It basically says, yes, disasters that we take into account are happening indeed fairly randomly.
Pinar, can I just interrupt you just for a second? The
Sure,
observations,
absolutely.
the 740,000 observations or 465,000, are these observations, individual contributions or?
This is county week level.
Okay,
donations.
and are you matching the, county? Are you trying to sort of difference or match the political or charitable on the county level, or just kind of doing each separate?
So we are going to use essentially the same shock will arrive, the same disaster shock is arriving, and for the same county, we are looking at the political giving, the change in political giving, and the change in charitable giving.
Okay, so there's
in that
740,000 counties or 740,000 counties
county weeks that are within the period of 2006 and 2011. That's the period of observation for us for charitable giving. No worries. So when we look at the political contributions, on the other hand, we actually see a decline and a negative, basically the effect that's significant at the 5% level. And there, the magnitude is slightly smaller. You can see that that's about a 7% decline in political giving that's taking place in the 6 weeks that is following a disaster. Now, let's go into sort of the interpretations of this. As I mentioned, basically this, these effects are happening together, and or sanity checks they're following. Doesn't seem like, at least based on the American Red Cross, there is some kind of intertemporal substitution. And the giving is mostly concentrated in the 6 weeks. So these are, I think, things. But the one thing we can think about here in terms of the ratio of the change, the increase versus the decrease in political giving, if you were to look at the degree of crowd out, that's about a factor of 0.26. So there seems to be some evidence that giving to charity and increased giving to charity actually crowds out giving to politics. So now I'm going to repeat this exercise, looking at a second perspective, looking at a sort of a political information shock. How does that affect giving to charity and giving to politics exercise, as I mentioned earlier? But I can imagine at this point, of course, many of you might say, how is it surprising, right? How is the fact that as I start giving to one account, there is some kind of a decrease? How is that surprising? Wouldn't you expect this if there's some kind of a budget constraint? And my answer to that is, I don't think that's that straightforward in the following sense. For, of course, any budget constraint to be in effect here, it has to be a binding constraint. So it has to be such that when I start giving dollars to one account, I'm completely consuming out whatever budget I have. And now I have to start thinking about, okay, where can I take away? Where can I take this increased donations to charity from? And especially if you think of people who give to either politics or give to charity, that may not necessarily be the case. I mean, I'm not saying that no one has a budget constraint, but it's unlikely to be the case for the average donor. On top of that, we wanted to be able to see if this is potentially in effect by doing a few tests on, for instance, looking at how other type of consumption, other forms of consumption are affected as these disaster shocks come. One thing we did, for instance, was to look at consumption of household goods using the retail scanner data from Nielsen, obtained from a University of Chicago Skills Center, so thanks to them. This is spending on a number of different items: food, non-food grocery items, health items, and so on. The data is approximately from 40 to 60,000 households. So we did the same exercise. Instead of the donations, we simply replaced the left-hand side of that equation, that specification, with the dollar spending in retail. And when we look at how the disaster shocks actually affect retail spending, we don't see an effect there. So, now going back to this, if this was a simple budget constraint, it's possible that people would start spending less on a number of different items. We don't see that at least effect on retail. Now, what could that simply imply? That could potentially imply something about maybe if people are starting to take away from political giving, maybe they do somehow combine these two things, these accounts in their mind, and that could be a mental accounting type of explanation. And that's not going to be against what we claim in this paper. But we do a number of other checks as well on top of the retail expenditures, other forms of consumption, including forms of hedonic consumption, and we don't find an evidence of cutting down on these other forms of consumption. This is not something that I would completely rule out, but it does not seem like this is supported in data. Okay. Now, let's go into the other form of evidence. What happens is there are more political information shocks that come into an area relative to another area. How much does that additional political information shock potentially affect giving to politics as well as charity? Now, here we cannot do the same exercise. Essentially, this is thinking about the DMAs, as many of you are familiar with, thinking about DMA boundaries and pairing counties that are basically next to each other in the DMA boundary that looks similar in many characteristics. But comparing somebody turned on their mic. Thinking about how much the additional spending in political advertising relative to the paired county might be driving additional giving to politics and maybe less giving to charity. That's going to be basically our strategy here. We're again going to have some kind of a falsification check that's going to be the giving in the month before the political advertising takes place. Now we do include a bunch of different controls, including some county, payer, and year and month fixed effects. So anything that's going on related to that county payer in general, that's time invariant should be taken into account. Okay. So the data here, the political advertising data, comes from various resources that are probably known to people who work in these topics. Wisconsin Advertising Project as well as Wesleyan. The source of these data is from Kantar Media, and what we know is when and where the ads have aired, the date, time, market station, television, the cost of these ads. In reality, of course, we are going to look at the county level aggregation of the amount of dollars that are spent in this area on political advertising. So how does the additional political advertising that's spent affect giving to politics, charity, as well as giving to other forms? Again, looking at the Nielsen consumption data. In the first two columns, what you can see is that there's about a 0.4% additional giving to politics with an additional dollar amount spent on one county, right? That's increasing giving to political candidates. At the same time, if we were to look at the charitable giving, we see a decline, slightly about tenfold less in the magnitude as potentially expected. But we don't see the same response in retail. We don't see that this is actually the additional dollars or the information shocks that are coming from political advertising does not seem to move retail. We have a bunch of different controls here. We also control for the effort of American Red Cross in terms of trying to get some additional dollars in terms of charitable donations. And we don't see that effect. So what does this correspond to? Now, looking at the other side of the medallion in some sense, political information shocks as well that arrived, or the additional political information shocks compared to the pair county, that increases giving to politics. A 10% increase in political ads leads to about a 0.9% increase in donations. At the same time, when you look at the same level of increase in political ad expenditure, we see a 0.77, again, almost a tenfold smaller, but we see a significant decrease in the charitable donations. And if we do a similar exercise as we did before, how much do political donations crowd out charitable donations? We see that that's about a factor of 0.08. So that's much smaller compared to the other way, the crowding out of the other way, but nevertheless, that's an important and not economically small crowd. So that's basically the major findings in the paper. We see that there's some kind of a relationship that if there is an information shock of one type, it increases the donations to the same type, at the same time decreases the donations to the other type. It does not seem like this relationship also exists for other forms of consumption. It doesn't seem like this is holding when we look at household consumption using retail data. But this also doesn't hold. I mean, I'm summarizing on the column 7 to 9, the retail essential spending, but this does also not seem to hold when we look at other forms of consumption. So I'm here showing the disaster dummies again, and how these foreign natural disasters, as they arrive, how that potentially affects household spending on lottery. Might be we pick lottery because it's an item that's not necessarily as vital to your survival. You should be able to cut that out. We don't see any decline. We don't see any change in that with the disasters that are happening. At the same time, you look at a second index of retail spending that's coming from Redbook. This is household retail spending on a greater number of items than compared to Nielsen. That includes clothing and for instance, stationery and so on. And here again, we don't see a change. So it doesn't seem like these information shocks are affecting at least looking at three different data sources, the type of consumption that people have. We also have a similar table that shows that additional political advertising also doesn't seem to affect other forms of consumption, but it does have a clear effect on political giving and charitable giving. So now how should we sort of put all of these together? That should be the question. I'll talk about the motivations or preferred explanations, but let me also show you a few more robustness checks that we have done. Now, as I mentioned earlier, we don't have enough information, or we have missingness of the donation dollars when we look at donations that are less than 200. That's just by the regulation of the reporting. It's not something that we can deal with, but we can nevertheless look at different dollar amounts of giving. And we can see if the effect that we observe is still surviving. And we've done that for different buckets of giving, less than 50, 50 to 200, 200,000, and greater than 5,000. In most of these accounts, at least the majority of these buckets, looking at the dollar amounts between 200 to 3,000, the point effects seem to be significant. So we see at least that the results that we observe is holding for a majority of the dollar amounts of giving. When people start giving too much, like greater than 5,000, there might be other reasons of giving. There might be, for instance, at that point, maybe I'm really having an influence on a local politician. So we don't necessarily expect those type of strategic motivations, donations, to be affected by the disasters that are happening. Those donations might have completely different motivations than the other forms of giving that we observe here, the small donations. At the same time, you can see that the noise level, when we start going down less than $200, it's quite high. So there, we want to be cautious of any kind of interpretation for these dollar amounts. Now, the same thing, of course, you might ask, what about political action committees? Because, you can also give to political action committees. You don't have to necessarily give to individuals. Now, one has to be a little more cautious about political action committees because these action committees do not have the same restrictions in terms of their spending as the candidates do, or their reporting requirements are much less. And in some ways, there's been literature that shows that giving to political action committees can be a lot more strategic. These are the dollars that are more hidden. So their motivations might not look the same as me giving as an individual to a particular candidate. So knowing into this analysis, we knew that. And that's also in line with what we are finding. There is a region, you can see that roughly around, if you look at these small numbers, there is a region where the dollar amounts of giving to political action committees also respond to shocks. And political advertising shocks as well as the disaster shocks. But this is, considering the entire range, much less sensitive. And that's something that we anticipated going into this. Okay, what else? We have looked at a bunch of other things. One question, of course, many of you probably have on your mind. Wouldn't you expect American Red Cross to adjust its mailing? right? Their efforts, if there is a political campaign going on, or if there is an intense political period. We look at, for instance, if they change the number of mailings that they send out to people, and we don't find an effect. And actually knowing in how American Red Cross in general does these appeals, they typically plan this out much more in advance. So, to the extent that the regional advertising shocks, the levels might be changing a little bit last minute, that may not perfectly correlate with their efforts. So I'm not surprised that there isn't an extra effort. We also don't see a significant change in their efforts as disasters come. That's because, again, they have a fairly stable system of regularly sending out mailings to potential donors, and that's quite large in size, millions and millions. And even if there are disasters that are happening, they're happening quite often, it might potentially change the content of the mailing, but it doesn't seem to change the number of mailings that people receive. We look at the extensive margin as well as, what we've been looking at is the intensive margin. We see indeed the same effect if we look at the number of donors as opposed to the donation amounts. We do tests around different fatality thresholds to see how sensitive our findings to the disaster definition. We don't see an effect there. We play with the year timeframes that we have. We look at individual donations, the donations to only Democratic individuals, candidates, Republican candidates, and we see the same effect replicating for both parties. So the results seem to be robust for quite a bit different specifications or small modifications around the main specifications we use. A second thing, I mentioned this already, but American Red Cross mailing efforts doesn't seem to respond to the political advertising shocks. That's perhaps not so surprising. But we also did another falsification check to see if the timing of advertising spending actually responds to the disaster shocks, and there we also do not find that it's sensitive. So we did a bunch of different things. Now, what could be the explanations, right? What are the possible explanations here? Altruism, the desire to see others be better is not an explanation here, because when foreign natural disasters happen, I don't have any reason to necessarily give to a domestic organization. Right? I might think that there might be a help happening overseas, but that's unlikely to be a driver. At the same time, I don't have any reason to take out from politics, right? That's just because, that has nothing to do with the welfare of people in another country. Mental accounting, as I referred to earlier, could be one possible explanation. To the extent that people see political and charitable donations somehow related to each other or see them as substitutes, they might also bucket them together in their mind, and as they start giving to one account, they might start taking away from the other account. So there might be some story like this that's going on. But our preferred explanation is that warm glow, the motivation of giving to others, because that potentially makes you feel better, right? Because, I give there's a disaster happening and I start giving to charitable organizations, and I feel better about myself. I'm a good individual. I'm someone who helps others or helps charitable organizations. At the same time, when there's a political campaign going on, I give to others because that makes me feel like I am participating in politics, trying to help others by getting the right candidate elected. That kind of warm glow that's about me feeling better could also drive both motivations together. And that, to us, is the main driver of the two, basically the substitution that we observed, the two changes that are happening as the same form of information comes. So that's something that we did. Let me show you a proof of concept of why we think these findings could be important. Now, even if you don't care about,
you have 10 minutes left.
Okay, thank you. Even if you didn't care about the motivations for political giving, which essentially addresses an important question that's been open in the literature, you might nevertheless care about these findings because as a proof of concept, what we're essentially suggesting is that as disaster shocks come, right, foreign disasters, that affects, of course, charitable giving in the United States, but that also acts as a potential instrument for political donations. So it's something that can exogenously change political donations. And having that as an instrument can help to answer a bunch of questions related to the effect of political donations or on some form of outcome. As a proof of concept, we provided that in the paper. Let me discuss, for instance, something that we do, but you can think of the other form, right? You can also think that additional political advertising might also be considered as an exogenous shifter of charitable giving. And for anyone interested in understanding how charitable forms of giving have an effect on some kind of outcome, this can be valuable. So there's also value for the researchers interested in understanding the effect of these forms of giving. So what we do here, we first of all try to estimate, as in the first equation, as an outcome of the disaster shocks that are happening, the charitable giving, how much does the disasters move charitable giving. Then we estimate, in this three-step procedure, we estimate how, if we can estimate the amount of charitable giving that's going to respond to disaster shocks, how that basically corresponds to the amount of political giving that's going to decline. And then we basically predict that instrumented political giving. We plug that in the third equation as the predictor of an outcome. For instance, the outcome could be the elections. Now, if we wanted to ask a question, and there are lots of economists who ask this question, how is more money in politics affect the chances of someone getting elected? Is more money in politics, is this a good thing? Is it helping the incumbents get elected? Is it helping the challengers get elected? Or is more money in politics a bad thing, right? And when I say bad, in general, the view has been that keeping an incumbent in seats might make political elections less competitive, and it might actually result in worse economic outcomes, worse policy outcomes, and so on. There's a literature that seems to argue that. Now, if we were to use this three-step procedure, here's what we find. Right? Additional political donations predicted by disasters, instrumented by disaster shocks, they actually predict a higher vote share for challengers. And we looked at the election outcomes. The higher likelihood, marginally significant, but a higher likelihood of win by challengers, and not an effect on the direct effect on the incumbents. But nevertheless, right, this is an important outcome, and to the extent that we wanted to understand the relationship between political donations and vote share of challengers or incumbents, we would want some kind of an instrument. Disasters act as an instrument here, so we can make a causal prediction. What this simply says is more money in politics actually could be a good thing, because lower political donations simply improve the chances of incumbents, or more money in political donations might actually help the challengers. There is an increase of about 1.2 percentage point if the political donations were to go up by 10%. And again, we can actually make these claims in a more causal way. This is in contrast with some of the existing literature in economics, so it's in that sense also important, because we think that we are able to use the disasters as an instrument shock on the political giving. So that's something important, again, I think, for research. Okay, couple other things. I have about 5 minutes before I can finish. Now, you might also ask this question: you're giving us some numbers or showing us some results based on American Red Cross. Now, American Red Cross might be a very specialized, very sort of stylized example here. We might not be able to generalize from American Red Cross, at least in that proof of concept that you've shown us. Maybe it's not really, that those magnitudes that you obtain are not necessarily trustable. And I can take this criticism. What we have done in order to see if our results are replicable for a number of different organizations, we try to go to Amturk and basically replicate the experiment. What we've done is to be able to replicate it successfully for American Red Cross or main organization, as well as American Cancer Society and Feeding America. Now, we do something slightly different here. We don't, of course, have these exogenous shocks, but we give information to the subjects about the organization. We think that's the information shock, moving the desire to give. Here, we basically have a split design where we first, as subjects come into the experiment, We asked them to allocate a $1 bonus to the charitable organization of focus, or to politics, political donations, or to keep it to self. That's another option that we have. And then we randomly allocate them into information conditions. No information or information about the charitable organization, or information about upcoming, this was before the Georgia state elections, upcoming Georgia state elections. The reasons for why we do this is simply because we want to remind people the importance of giving to these accounts. And then we re-elicit their preferences of the same $1 allocation. And then we compare groups that have received these information shocks to groups that did not. So that's the main thing. Just excuse me for a second. Okay, this is a couple screenshots from our experiments. No info condition where we tell them they're not selected to receive an information. And in the charitable information condition, we tell them about the things that American Red Cross is doing. In politics, we tell them about the upcoming Georgia state elections, and then we do a realistic, and then we do a comparison. For American Cancer Society, we had a message related to the organization again, and for Feeding America, we had a message related to Feeding America as another organization. Now, we were a little, as we went into these experiments, we didn't necessarily expect maybe the same level of movement for all these three organizations. It might just be that there are differences across organizations in terms of how urgent people think it is to give, or how much the organizations actually are able to convert the dollars that are given to goodness. But we didn't nevertheless see much of a difference. So what we are doing, essentially also a side note, we try to keep these experiments as powered as possible. For American Red Cross, sorry, we recruited 3,000 people. For the other organizations, it was about 1,000 people. There was no deception.
You have 2 minutes left.
Okay, that was just mention this. There was no deception. Whatever was their choice of allocation, we eventually also donated those dollars to the organization. So what I can show, these are graphs, but roughly let me summarize what we are finding. At least looking at American Red Cross, we see the same thing. As you start giving the charitable information, people are starting to give to charity, and they start decreasing the donations, taking that away from politics. That degree of crowding out for American Red Cross, $1 in charitable giving, crowding out about 40 cents of political giving. And then for the opposite, political information treatment, again, an increased political giving, a decrease in charitable giving. And the crowding out, at least for the experiment that we have done, is actually larger for political giving. A dollar that's given into politics takes away about 68 cents out of charitable giving. So what we're finding overall are the two types of donations are close substitutes, consistent with a warm glow explanation. We replicated this also with another organization, Catholic Relief Services, which we expect there might be different motivations to giving to a Catholic Relief Service organization, but we nevertheless can also replicate this using a second form of observational data. But let me thank everyone. Thanks everyone for staying with me, even though I've started losing my voice towards the end. And I look forward to Hernan's discussion now. Thank you so much.
Thank you, Pinar. Hernan, so can you share your own slides, or do you want my?
I'm going to try to share my slides. It's the first time I use Teams in my life. Let me see. Should be possible. Let me see. Do you see the slides?
Yes, but it's not in full screen.
Yes, I need to go full screen. View. Full screen. Okay, do you see the slides?
Yeah, that's great.
Okay, I'm going to go really quickly. I have a very short time. I really enjoy this paper. I learned a lot. The first thing I want to say is something that, just to put this research into context, when I was reading the paper and I saw that donations are 2% of GDP, I thought that's a lot. That's a huge number. And I actually Googled is this even possible? And it is true. It is 2% of GDP. And just to put this into context, 2% of GDP is what countries spend in defense. And this was a number that was very much discussed between Trump and Merkel last year, because Trump was complaining that Europeans don't spend enough money on defense and the US has to pay for the whole world. And I'm just saying this because this is an enormous number. And so anything that can move the amount of donations of such large magnitudes, it's a question worth researching. I want to say something about the hypothesis. Well, I mean, you just heard it. So the whole idea of this research is to look at this substitution between political donations and charitable donations, because supposedly they fulfill the same underlying need. The warm glow, other seeing needs. Something that perhaps, and I think Pinar already mentioned this, is it's very hard to know the underlying mechanism. So we have a phenomenon, which is the need to donate, and we have sort of the empirical outcome, which is we see donations. The question is, are we really seeing the effect of substitution? And this is something that was already discussed in the presentation. Of course, first thing that came to my mind, budget constraints. I think the authors have thought a lot about this. Is this really mental accounting or not? And I think this is something really hard to elucidate with aggregate data. I think the authors have done a lot of robustness to really show that it's not just budget constraints. I still have some sense that there could be some idea of budget constraints, because it is possible that individuals have an amount that they want to donate, and once they don't donate to some charity, they don't want to donate to another charity. There could be some tax implications. I don't know the rules in the United States. I remember when I was donating to the Médecins Sans Frontières in France, there was a limit to what you can deduct from taxes, and maybe for some people that acts as some kind of budget constraint, so that either I donate to some or to others. So we should keep that in mind. The second is the question of aggregation. We're looking at aggregate donations at the county level, which is relatively granular, but we don't know whether they're the same people who are changing their behavior. Most likely yes, but this is something that, we need different data to study. To me, one question is, should we care what the underlying mechanism is? I was very happy to see the effect, and the effect, I believe it's real. Now, do we care what's happening in the minds of people? Maybe this depends whether you're a psychologist or more an economist or more like a marketing person. The effect is there, and we still don't know exactly what's going on in the psychology of the individual, but we can make policy decisions and even like advertising decisions based on this. The model, I'm not going to mention much about the model, you just saw it. Something like, I like that Pinar highlighted this. When I saw this model, I was thinking, oh, that's a very interesting model. I know we have sort of dummy variables for the periods, but that's actually works really well, because the idea of these regressions is to compare the effect of, let's say, a disaster on charitable donations and a disaster on political donations. So we have this alpha 1 here in this slide, and also the alpha 1 in this slide for sort of did I? Okay, so I don't know if I'm using I'm adding subscripts to the equations. So we have these two equations that basically there is an event and we see the effect on political donations and charitable donations, and we can compare these coefficients, which is really, really nice. And so this approach allows us to have this kind of very sort of the same sort of regression and this one coefficient that we can estimate and compare. I decided to draw some DIGs. Why not? Just to understand this better. So here C is charitable donations and P is political donations. D is disasters and A is advertising. So this is like in a nutshell how I understand the model. We're trying to understand the substitutability between C and P. So that's the arrow that goes from C to P and from P to C. And we have this exogenous shock called disasters and also the advertising. So this is what we are trying to see. Important is to think, is there any reason to think that a disaster may change the way people donate to politics? And is there any way to think that the advertising, political advertising may change charity donations? I don't know. I don't think so. I think in order to draw this gray line that I draw here, that would perhaps affect the way we think about this problem, we need a good theoretical reason. And I don't think there is such a theoretical reason. But I think it's good to draw the DAG, to start thinking about what are we studying. Also interesting is to think about alternative ways of estimating this model, because you can also think, let me go back one slide. If you think of the picture on the left, we have the effect of charitable donations on political donations, the substitutability, and we have D, this exogenous variable. So we can also think, I mean, if you show this picture to an econometric student, they would think, okay, we can use D as an instrument to study this effect. So there could be other ways to think about the model by looking at these DAGs. I think I want to talk about the mailings a little bit. I believe the mailings are exogenous, and in fact, this is not a criticism. On the contrary, I want to bring some attention to this. Mailings here. Let's talk about the mailings to the Red Cross. They influence the donations to charity, and in turn, charity donations, because of substitutability, influence the donations to politics. And the claim of the paper is that mailings are exogenous. So there could be a situation where a disaster triggers a mailing. That was the case for me when I donated to charities earlier. There was an earthquake, and I got the mailing, and I donated. Now the explanation from the authors is that the mailings are decided in advance, and so there's no way to react to a disaster by increasing mailing. That would change a little bit the model. And I believe that. And this is the great thing about looking at the American Red Cross, is that we're looking at disasters, and we're looking at a period of 6 weeks. We cannot change an advertising campaign in 6 weeks. It's really hard. Advertising budgets are set at the quarter level. Mailings are sometimes scheduled over a whole year. I know that from the mailing industry. I know it from the catalog industry in the B2B setting. So it's always important to think about this scheduling and this budgeting of advertising to make the claim that these things are indeed exogenous. And I believe in this case it is. But I want to bring the attention that a lot of advertising, we tend to think immediately, oh, it's endogenous. But not in the short term. In the short term, it's really hard to change the schedule of these mailings. What else we can talk about? I think it's important to bring some attention to the crowding out effect. I really like how these coefficients were compared by, in this case with a ratio, but you can imagine other comparisons. Maybe I'm thinking too much like a Bayesian, but I always think of the coefficients as having some distribution or some uncertainty. And I think it's important to also report the uncertainty of this ratio. It's relatively large. I'm using some quick calculations. I'm assuming the standard errors that I see on the regression and some kind of normality, and I'm doing some confidence interval here to show that this, the effect is clear, 0.14, the crowding out effect, but there is quite a bit of uncertainty around that effect that could go from 1% to 44%. By the way, this is, I wouldn't say back of the envelope because I used a simulation to do this, but it's a very simple analysis. Also, and very quickly, we have two regressions, and there's no way to assume. Should we assume that the regressions are independent? Or are the error terms in this regression somehow affected by the same shocks? I don't know. It's hard to know. But if you assume that these epsilons are actually bivariate, they have some correlation, that will affect this is actually there's a typo here. There should be the correlation between the alphas. If, for example, if rho is negative, so if the epsilons are negatively correlated, the alpha ones, so there's a typo here, the alpha ones are also going to be negatively correlated. So you estimate the alpha ones, if one is higher, the other one is going to be lower. That will increase the uncertainty of the comparison. Is this a problem here? Not really. It's something to keep in mind if you want to estimate these kind of models. The parameters are consistent. This doesn't affect the bias or the consistency. In the case of rho positive, this is actually good news for the estimation because the parameters would move in the same direction. So the ratio actually would have a smaller uncertainty. Plus, this is not an issue. Given the number of observations the authors have, maybe we shouldn't be too concerned about this. But this is something to think about when we think about how do we model crowding out effects in other contexts. Okay, conclusions. I don't know, I'm running out of time. What have we learned? So I have learned that the effect, so there are two different results, if you know, the effect of the disasters on donations and the effect of advertising on donations. To me, the most interesting result is the effect of disasters. It's truly an interesting, creative way of using this information. If I have to bet, 1,000 euros, whether these results replicate, I would say yes, given the amount of robustness and the size of the data sets. It seems to be a very robust result. If I had to choose where to put my 1,000 euros on the effect on charitable donations or on the effect of political donations, I would go for the charitable donations. It seems like a very clear effect of an exogenous variable. The effects are larger. Going to the next item, do we think the effects are economically significant? To some extent, yes. The effect of advertising on political campaigns is relatively small, but that's the nature of advertising. If we have learned something in the last few years, is that the effects of advertising tend to be smaller than we expect. But the effect of political advertising on charitable donations is kind of small. It's 0.7%. Is that something that would change the behavior of a manager or of a charity? I don't know. That's something that everyone should decide for themselves. The statistics are clear. There is a real effect there. Whether that matters, it depends on the context. For example, I'm thinking less of like an economist and more like a marketing manager, and thinking, okay, there's a disaster now. I'm the marketing manager of a political campaign. What should I do? Should I increase my advertising or should I turn it off? Okay, so that's an interesting question. I cannot answer that question because I need to see a little bit of how the parameters would move. But that's the question we need to think about if you think about advertising. And in this case, the size of these parameters do matter. How could I improve the paper? I don't know. I think it's a paper. I learned a lot on how to write a very clear paper. One thing that I would like to try if I had the data, I don't know, maybe the authors already tried it, is that I wouldn't treat all the disasters the same. Here, please, maybe Pinar can correct me if I'm wrong, but all the disasters are just one dummy. But there are different intensities of disasters. There is different types of disasters. There are disasters to take place in faraway places. Is it the same if an earthquake in Haiti or an earthquake in, I don't know, somewhere in the Middle East? Is it the same for Americans? So I don't know. The authors wrote the papers they wanted to write, not the paper I want to write. But this is something that I would definitely like to understand better, because that would also inform a manager that has to react to a disaster. And I guess that's it. I learned a lot from this paper. I want to say that it's really well written, and it has changed the way I am thinking about one of my papers and how to rewrite it just by reading this paper. So I recommend everyone should take a look at the paper as a whole. Thank you.
Thank you.
How do I undo this? Can you?
Thank you. I think the next presenter, when they share, you undid it.
Okay, I'm sorry.
Yeah.
Bye.
Thank you.
Bye.
Hi, you can start whenever you're ready. And I'm your timekeeper, so at the end, like last 10 minutes, I'll let you know. So you can have a time.
Yeah, wonderful. Can you see my slides okay?
Yes, everything's perfect.
Okay. Yeah. I mean, same as the earlier speakers, it's my first time use the Microsoft Teams. So if anyone have any questions, please just feel free to speak up. Or Sugard, if you can remind me if there is any hands up, I would really appreciate that.
Okay, sure. Yeah.
Okay. Let's see. Hello, everyone. My name is Zhang. I'm from London Business School. Thank you so much for taking the time to attend this talk. Today, I'm going to talk about TV advertising and online sales, the role of intertemporal substitution. This is a joint work with my colleague at LBS, Anja Lambrecht, and also CatherineTucker from MIT. So the first question before I dive into the research project is what motivates us to look into this topic? If we think about the recent years, we observe two different kind of trends. One trend is on the consumer side, the other trend is on the company side. So the first trend is that digital technology has enabled consumers to respond to the offline TV advertising instantaneously by engaging with the company and also their products via online channel. And the second trend is we see companies increasingly aiming to coordinate their offline TV advertising effort with the online activities. Because of the coexistence of those two trends, what we have seen is that those two trends kind of begged for some consistent measurement of the TV advertising effectiveness on online activities. As a result, in the industry, there is an increasing group of companies who are currently providing new methods to do this measurement problem. Here, I just listed a couple of them from that big group of companies. Well, why those companies are able to do that is because of the data richness that they have. Nowadays, for a lot of companies, they can easily access the data of their TV advertising data and also the granular online consumer data. Okay, so now let's think about those two types of data. When we have the granular online consumer behavior data, and when we want to link that online consumer behavior data with the offline TV advertising data, then the first problem coming to mind is the endogeneity problem. As we all know, advertising decisions are not made exogenously. When the advertising will be shown and how much money that we want to spend on advertising, those are all endogenously decided by company. So as a result, in order to overcome that endogeneity problem, what those data analytics companies are currently doing is the industry standard is we're going to look at a very natural attribution window. Why the natural attribution window works is because when we start to use the natural attribution window, for example, if there is a TV ad spot at 8 p.m., I look at 5 minutes before, compare that to 5 minutes after. We hope that narrow attribution window can give us a very sharp identification. So it seems like those kind of event study work really well. But if you think more carefully, there are two types of problems. What are those problems? Those narrow attribution windows may abstract away from the intertemporal elements. So there are two types of those elements. The first one is, if we think about 5 minutes before and 5 minutes after, what if the consumers may actually take longer than 5 minutes to make a purchase? If that happens, then using the narrow attribution window will result in an underestimation of the TV ad effectiveness estimate. And there is a second possibility, that is, consumers may actually move the purchase forward in time due to the exposure to TV advertising. If that happens, then using the natural attribution window will result in an overestimation of the TV ad effectiveness. So now facing those kind of problems, and clearly the industry standard solution using the narrow attribution window doesn't solve those problems. So this is what we're going to do in this project. The objective of this research are threefold. The first one is we want to see whether the natural attribution windows are desirable or not. Okay. And second, we want to see whether the natural attribution windows would miss any important consumer behavior out. And the last thing we want to see is if there does exist some concerns about using the natural attribution windows to link the offline TV advertising with the online consumer behavior, then what can companies actually do in order to get a consistent estimate? Okay, so let me first give you a preview of the results. What we did in this project is we're going to utilize the data from a field test conducted by a world's leading online travel agency. For this company, it exogenously varied the exposure to TV advertising across the different regions of consumers in one of the European countries. And by using that data set, we first confirmed what is a common belief in the industry, that is, the TV advertising indeed have a positive effect on browsing and sales immediately. In other words, this is what the industry has called the positive spike of the TV advertising on online behavior. But then we also find that this kind of positive spike out of the TV advertising, it comes at a cost of lower activity at later point in time. So in other words, this seems to suggest that consumers actually involved in this intertemporal substitution behavior. Due to the exposure of TV advertising, they are moving their future purchase forward in time, okay? And then at the end, we also show that the intertemporal substitution effects varies across different customer segments, and this substitution effect has some important implications on consumers' promotion usage. Okay, so this project is related to 4 streams of literature. The first one is a very recent kind of emerging stream of literature, is to link the offline TV advertising with the online consumer behavior. In the past 5 to 10 years, a lot of researchers have looked at different aspects of the online consumer behavior. For example, the online browsing, the online sales, the online chatting. So our today's discussant, Sash, has a paper about this topic. And the second related stream of literature is about the TV advertising effectiveness more general. If we think about the first stream of literature, most of them focus on a very tight attribution window, and majority of them find the positive significant results. But then if we look at the TV advertising effectiveness more generally, a lot of recent papers, they find that for a lot of big TV advertising campaign, the overall effect is not significant different from 0. So we hope like our paper is kind of providing an underlying mechanism, potential underlying mechanism that can reconcile those 2 streams of literature. And the third related literature is about intertemporal substitution. In the past, researchers have already documented consumers' intertemporal substitution behavior when it comes to the price promotion, and also when it comes to like the mail catalog advertising. But today we're going to focus on TV advertising will lead to consumers' intertemporal substitution when it comes to the online behavior. And the last one is about advertising measurement more generally. Recently, Gordon et al. Have 2 papers looking at pros and cons of experimental data versus observational data, and how should a firm utilize either type of data. So we hope this project can also speak to that stream of literature. Okay. Any questions so far? Okay. Let me just move on. So let me talk more about the empirical setting. As I mentioned earlier, the data that we're going to leverage is a field test data. This field test was conducted by one of the world's leading online travel company. It is one of the top 5, and it is conducted at the end of 2015. The company sells hotel stays all around the world. This field test was conducted in one of the European countries. In this test, the company kind of splits the country into 2 different types of regions. One is a TV advertising region, and the other is a control region. For the TV advertising region, it includes 11 counties, while the control region, it includes about 115 counties. During the whole test period, we have about 6 weeks. The first 4 weeks are the pre-treatment periods, during which there is no TV advertising was displayed to anyone in the country, but followed by a 2-week treatment period, during which time the TV advertising was only displayed in the treated region. For the TV advertising campaign, the company made sure that when they designed this campaign, it was comparable in weight, in length, and in terms of content to the previous TV campaigns of the company. So just one note here, due to the non-disclosure agreement with the company, we're not able to dive into the detail about how does the TV advertising content would moderate this TV advertising effectiveness on the online consumer behavior. Regarding the TV advertising content, there are, I think, 2 or 3 papers on that topic. If you're interested, I believe Yura and Ken, a couple of others have a paper on that. And Guitard and Stramach, the last year, like on GMR, they have another paper looking at like emotional content versus informational content, or actionable content versus emotional content. What is the relative impact on the TV advertising effectiveness? So this is a setting. And from the company, we're able to collect 2 types of data. The first type of data is the consumer online clickstream data. Through the online consumer clickstream data, we're able to observe the detailed timestamp of a consumer's visit, the location where the consumer is at, and the device that the consumer used through which channel, and the basic page content via the URL analysis. About the TV advertising data, we know the exact ad time, the advertising length, the cost per spot, and also the television rating. By combining those 2 types of the data, we created panel data at the county 30-minute level. Okay, so the main result that I'm going to present you today is at this level, because we want to achieve a good balance between the data sparseness and also still keep a good variation in the data. But in the robustness check, we're going to check different time window levels. For the dependent variable, what we care about is the online browsing measured by the number of sessions, and online sales measured by the amount of sales. For the key independent variable, that is the treatment variable, which is the TV advertising spending. Here are some summary statistics of the data. Let's start with the consumer online data. Over the whole campaign period, plus the pre-treatment period, during that 6-week period, we observed about 5 million online sessions. So the sessions here are defined as between 2 sessions, there will be at least 30 minutes of online inactivity. And for on average, within each session, consumer would browse about 11 different web pages. They spend 6 to 7 minutes, and the conversion rate is about 6%. Among those transactions, consumer would spend about $600 on a 3.5 hotel star rating hotel for about 2 and 2 days. Okay, so this is the overview of the consumer online browse behavior data. Here it comes to the advertising data. These 2 figures, I want to show you the advertising variation during the campaign period. The left panel presents the advertising variation by date, and the right panel presents advertising variation by the hour of the day. So clearly you can see that there are a lot of variation going on by either the date and the hour of the day. The blue solid line captures the advertising spending, and then the red dashed line captures the advertising length measured in seconds. So we're going to use both of those measurements in the analysis. Okay, before I dive into the research design of the paper, I want to first to show you, like, let's assume if we use the industry standard to use the event study with a very tight attribution window, how does the data pattern looks like. So if we think about industry approach, what they have is oftentimes they have the offline TV advertising, they have the online consumer behavior data, but what they don't have is they don't have a very clean control group, and oftentimes they don't have the access to the pre-treatment period data. So here, I'm just assuming, what if we only have the data access to the treatment period and the treated region data, and utilizing an event study to see what will happen? So here is the result. Consistent with that positive spike belief, when there is a TV ad, then we see that comparing the post 2 minutes to the previous 2 minutes, or post 10 to pre-10, or post 30 to pre-30 minutes, we do find that advertising can significantly increase the amount of browsing in the online website. Okay, so this is what we see from that kind of correlational study by the event study. But another thing that we can see is that if we look at the aggregate effect of the TV advertising, then actually over the whole time period, the effect is not significantly different from 0. So here there is this inconsistency here. If we always see that the TV advertising can drive up the traffic and the sales immediately to a very large magnitude, why don't we see any positive effect over the whole TV campaign period? Well, you may think this is a power issue, but here, hopefully, for the following analysis that I'm going to show you, that I can convince you, we think the main reason behind this non-effect over the whole campaign period is because of consumers' intertemporal substitution behavior. Okay, so because of the inconsistency between the event study positive results and the non-effect overall, so here comes our research design. Remember, the advantage that we have the data is that we have a very clean control group, and also we have the pre-treatment data, pre-treatment period data. So that is why at the starting point, we're going to use a difference in difference. This is our baseline specification. Here, we're just focusing on the immediate effect of TV advertising, just like what we had seen in the event study. For the outcome variable, it will be the log of number of sessions or the log of amount of sales. Okay, AIT represents the treatment variable, which is the log of advertising spending in the same kind of time window. This beta 0 captures the immediate effect of TV advertising on sessions or sales. In this analysis, we control for the date and hour of the day fixed effects. We also control for the county fixed effects. For the Artem, we clustered it at the county level, but alternatively, because we know this is a panel structure, so we also use the New West approach to account for the possible serial correlations and also the heteroscedasticity. Okay, so this is just a starting point. This is a baseline regression. But when we think about this baseline regression, clearly there is some problem with it. Because even though we have a clean control group, we have the pre-treatment period, but the problem is because we're not just focusing on the event study 2 minutes before, 2 minutes after, we're actually capturing all the time windows during the whole campaign period. So as a result, the TV advertising carryover may play a role in the outcome variable. So that is why in addition to the baseline specification, here in the second specification, we're going to further add on the carryover effect. What we have here is AIT minus tau. We're trying to control for the TV advertising spending in the same county, but in the time window T minus 12. Okay, so tau time period before this TV ad spot. And this beta tau captures the carryover effects of TV advertising on sessions and sales. Any questions? Okay, so up to now, everything seems to be very standard. Like I didn't do anything fancy. This is just a very standard difference in different setting. But because of the advertising lasting effect, so I control for the carryover effect. But the next slide is the key part of this paper, which is the intertemporal substitution. How we're able to capture the intertemporal substitution is through this dummy term. This indicator indicates a time window in the TV region that is in the treated period, but does not receive a TV ad. Okay, so now let's think more detail about this variable. What this indicator is if you only have the data access to the treated region, then you need to assume that during those hours when there is no TV ad, then the online activity during that period serves as the baseline so that you can identify the TV ad effect. But here, because we have the control group, so we are able to add in this indicator variable for the treated region to allow that baseline when there is no TV ad to be different between the treated group and the control group. And as a result, this alpha captures the intertemporal substitution. Okay. So for the validity of this identification strategy, we need 3 assumptions. The first assumption, we all know, for the diff in diff, we need the parallel trend during the pre-treatment period. Let me first show you some visual inspection. So here shows the visual inspection of the number of sessions and amount of sales in both the absolute terms as well as in the log terms during the pre-treatment period. Okay, so just by visual inspection, it seems like the parallel trend holds okay. And also we run an analysis to see whether there is differential linear trend between the treated and the control region. So we're going to look at this alpha 2. If there's alpha 2 is significant, then it seems to suggest that at least the linear trend is different between the 2 regions, so the parallel trend doesn't hold. But here what we see is that alpha 2 is not significant. So it seems like at least for the 2 regions, the linear trend are parallel. Okay, so that is the first assumption that we need for the validity of this identification strategy. The second assumption we need is we need to make sure there is no other marketing activity specific to the TV region happen during the treatment period. By the conversation with the company, we made sure that there is nothing specific happening to the TV region during that specific period. And the last assumption we need is we need to make sure there is no competitor's strategic response. Because of the treated region and also the treated time period are private information for the focal company. So we do believe that this assumption will hold. So given those 3 assumptions, we think like diff in diff analysis should be valid. But some of you may question, like, if we look at this trend here, clearly this is very concerning, because there exists a big gap between the treated region and the control region. So that is why we're also going to use 2 alternative approaches. The first one is we're going to use a border strategy. Okay. For the border strategy, we're going to focus on those treated treated counties and control counties, those located within 50 miles of the border. Okay. So what we find is that, let me just show you some summary statistics. What the purple boxes highlighted is the original comparison between the treated group and the original control group. But as soon as we just focus on the bordered counties, then the red box highlighted the comparison between the bordered treated group and also the control group. Clearly here, the comparability between the 2 groups have improved dramatically because of the border strategy. So that is the second identification strategy that we're going to use. And the third identification strategy is the synthetic control. Using the synthetic control, we can ensure that the possible unobserved confoundings that are correlated with the TV advertising and some online outcome variables will not affect our results. So similarly, the purple box highlights original comparison. And if we look at the red boxes, now after the synthetic control approach, the treated group and the synthetic control group becomes much more comparable to each other. Okay, so now I talked about all the different identification strategy. Let me show you some results. So this is the first set of the results. Okay, so this result is from difference in difference. And here we're not thinking about intertemporal substitution. Let's just focus on the immediate and the carryover effect. So the first row shows you the immediate effect. And also we control for like 5 lag terms. That is about like 3 hours post a TV ad spot. What we find that immediate effect is positively significant. So if the companies only rely on the result from this regression, then this seems to be a great news for them. The positive immediate effect shows that TV advertising is super effective in driving up the online traffic and also the online sales. But the thing is, as soon as we're adding this intertemporal substitution indicator, remember, this indicator equals to 1 if it is in a time window in the treated region, in the treated period, but there is no TV advertising was shown, okay? So for this indicator, we see that all the estimates are negative, significant. What that means is that those positive immediate effect and the positive carryover effect are coming at a cost of the later lower activity in the same region compared to the control region. So this is the first takeaway from this analysis is if a company just focus on the natural attribution window, then it will give them very misleading result. As soon as they look at intertemporal substitution and the positive immediate and carryover effects, then the conclusion will be different. Whether the TV ad will be effective or not, it becomes questionable. Okay. The second, so the aggregate effect, as I showed you before, also confirms that overall the aggregate effect is not significant out of this TV ad campaign. So the second takeaway from this table is I want to draw your attention to this immediate effect. So this highlighted red box shows you the immediate effect estimates after we control for the intertemporal substitution. But compared with the earlier table, when we do not control for the intertemporal substitution, between those two tables, we can see that, well, even for the immediate effect, it can be easily overestimated, okay? If we do not control for the intertemporal substitution, then the baseline will be different. And that baseline difference will result in the overestimation of the immediate effect. So that is another reason why looking into the intertemporal substitution effect is super important for the companies to consistently estimate the TV ad effectiveness. And the third takeaway is I want to draw your attention by comparing the sessions result to the sales result. If you look at the sessions result and the sales result, it's kind of surprising because what we have seen here is that sales are actually more elastic to TV advertising than sessions. This is very counterintuitive because for us, when we think about the effect of TV advertising, usually it will have the upper funnel outcomes will be more elastic than the lower funnel outcomes. But here we see an opposite pattern. Why that is happening? I'm going to discuss about this finding in the next part of the presentation. Okay, so the next slide is just to show you for this main result, of the baseline result of the paper, it also holds for the border strategy and the synthetic control. We do observe the significant positive effect of the immediate effect and also a negative intertemporal substitution effect. For those results, we tested a bunch of robustness. The results are robust to the different kind of specifications when we change the measurement from the advertising lens to the advertising spending, or change the dependent variable from the log values to the absolute values, or change the time window from 30 minutes to 10 minutes or 1 hour, all the results holds. And also we test the robustness of the synthetic control results by using alternative synthetic control weights. Let me just give you a quick summary of the key findings so far. We find that it is insufficient for companies to consistently evaluate the effect of a TV campaign by focusing exclusively on narrow attribution window. Okay, for the narrow attribution window, we're going to miss some important consumer behavior. And we find that immediate effect of TV advertising may be overestimated when we not account for the intertemporal substitution. And also we find that elasticity of TV advertising on sales can be actually bigger than that on sessions. So now I want to dive into the last point to see why the sales are more elastic to the TV advertising than the sessions. So here we're going to explore the effect on the number of transactions and the value of transactions. So talking about sales, first thing is I decompose the sales into 2 different components. One is the number of transactions, and the second is the average sales amount per transaction. Okay, so let's first focus on the number of transactions. If you compare the estimate here for the number of transactions as a result of TV advertising, the result is pretty intuitive because the magnitudes are comparable to the changes in the number of sessions. Well, clearly, when there is a change in the number of browsing sessions, that is very likely to result in the change of number of transactions. Okay, so for the first column, everything is intuitive. But for the second column, what we have seen is that when there is a TV advertising, immediately followed by that, then we see the average sales per transaction increase at a cost of lowering the average sales for the future transactions. So now we want to explore what is happening, what is going on behind the change in the value of transaction. What we did is we tested 4 different hypotheses. So the first hypothesis is we want to see whether the TV advertising has any impact on consumers' engagement. The story here is that if TV advertising can change consumers' engagement on the platform, then very likely they are going to browse different products and they may purchase different value of products. So that is why we see a change in the value, in the transaction value. But then what we find here is that TV advertising shifts neither the number of pages browsed nor the average duration of the session. So we use the number of pages browsed per session and the average duration of the session as a proxy for the customer engagement on the platform. And based on those 2 measures, none of them shows any changes or any responses to TV advertising. So we ruled out of the first hypothesis. And the second hypothesis that we have is, does TV advertising motivate consumers to buy higher value products? Okay, so here maybe because consumers, after exposing to a TV advertising, they start to browse different kind of products. Before they only browse like 2 or 3 star hotels. Now they're browsing like 4 or 5 star hotels. Is that happening in our data? Well, by looking at the trip length measured in the hotel stay days or the hotel star ratings, we find there is no effect of TV advertising on either of those outcomes. Okay, so basically we ruled out the second hypothesis here too. And then
sorry to interrupt, we have 10 minutes left.
Yeah, thank you. I think I should be able to finish on time. The third hypothesis that we have is maybe it's because the TV advertising affects the purchase of discounted products. So this one is little bit different from the second hypothesis. Second hypothesis is about consumers are buying different kind of products, but this hypothesis is saying that maybe consumers are still purchasing the same kind of hotel, but at a different level of price. If that's the case, so here are some results. What we did here is for each sessions, we kind of categorize each session into two kind of categories. One category is the left panel, that is the sessions without a price promotion page visit. The left panel are those sessions with a price promotion focused web page visit. Okay. So all those price promotion focused web page visit or not, those information are get from the URL analysis. And what we find here is that for those people who visit the website, but they do not visit price promotion focused web page, they would respond to the TV advertising positively right after TV advertising. But then the intertemporal substitution is not significant for those people. But then for those sessions, actually with the price promotion visit, those are the sessions that has been moving forward due to the exposure of TV advertising. So if you combine those two panels together, then the data suggests that TV ads actually shifts consumers away from visiting price promotion focused web pages to focus on more broader product offerings. And as a result, even though they are still buying the same hotel stay length at the similar hotel star rating, but now they're using less price promotions. As a result, they are paying more for the same kind of product. And we also find some other supporting evidence for this hypothesis is to look at across different channels. So in the data, we're able to know which channel a consumer coming from. And specifically, I want to draw your attention to this email channel. As we all know, email channel is very famous for sending coupons, price promotions to consumers. But interesting, what we find here is that for the email channels, it doesn't show a positive spike right after TV advertising, which kind of makes sense because when there is a TV advertising, like consumers will instantly like go to Google and then search for product or directly go to the web page. But it's very unlikely for consumer search for the email and then search for this hotel link. But what we see from the email channel is a lot of consumers actually, like during those non-TV ad spot time period, there is a decrease in the activity from the email. So this suggests that instead of being reminded by email that advertisers send out to advertise a price promotion, now consumers are prompted to visit the website following a TV ad. And here, because in our context, this TV advertising is not a price promotion focused TV advertising. And when the consumers are being prompted to visit the website following this TV ad, they are less likely to resort to their email to find a price promotion coupon to be used in their transaction. So that is kind of a side benefit out from this intertemporal substitution. The intertemporal substitution made consumers less likely to rely on the price promotion. Okay, so we do find some supporting evidence for this third hypothesis. And the last hypothesis that we test for this change in the transaction value as a response to the TV advertising is, we think maybe TV advertising have some heterogeneous effects on different types of consumers. Well, one thing that is lacking in the data is we don't have a lot of characteristics about the consumer side. So when we define the different type of consumers, we're still going to rely on their behavior. What we did here is we're going to look at those single visit sessions versus those multiple visit sessions. So for those single visit sessions, those are more likely to be like inexperienced or new users to the website. But for the multiple visit sessions, they're more likely to be experienced users, or they have already have a kind of upcoming trip in mind to be planned. And then, so they visit the website a couple of times. Their purchase likelihood is higher than the single visit sessions. Comparing those two types of segments, what we see here is that among the single visit sessions, TV advertising can make them to visit a website immediately, okay? But it doesn't come at a cost of lowering the future activity. This is not surprising because TV advertising can also improve like the awareness or some other aspect, perception, brand perception among the consumers, especially among those new consumers. So that is why we see here like this kind of pure increase for the single visit session users. But then for the multiple visit sessions, what we observe is both the positive immediate effect as well as the negative intertemporal substitution. For those consumers who has a trip plan in mind, then they are being prompted by the TV advertising and then visit the website, make the purchase immediately at the cost of lowering the activities in the future, okay? So this is the last hypothesis, and this is a supporting evidence for that hypothesis. We find that intertemporal substitution effects, it mainly happen among those multi-visit consumers, but not among those newer single-visit consumers. So here are 4 different hypotheses that we tested for the reason behind changes in the transaction value. And we do find that TV advertising affects the purchase of the discounted products, and TV advertising does have an impact on the customer mix. Okay, so at the end, for the last 2 or 3 minutes, let me just talk about a couple of concluding thoughts. So quick, yes.
Can I ask a question?
Yes.
Hi, this is Jiho. So you're trying to look at the impact, differential impact on consumers. I understand that you don't have a whole lot of data on consumers, so you're using the single versus multiple visit. But I was wondering, maybe even if only for a subset of the consumers, you can capture them by their behavior, by the products. So if they decide to respond, for example, make a purchase, make a reservation, say for hotels, and then we can look and say, okay, for the people who book 2-star hotels, the people who book 3-star hotels, how does ad respond to those kind of things? I know it's not exact consumers, but it gives you something informative that the firms may be interested in. Just a thought.
Yeah. Thank you for the suggestion. So that is actually what we tested in the second point. It's about like what kind of hotel that they book. Is it 2-star or 3-star? And then do they like make the trip longer? Is it 2 days or 3 days? But here, like we don't see any significant results.
All right, thanks.
Yeah, thank you. Okay, so just some concluding thoughts. In this paper, first we find that actually tight attribution windows, that is the thing that commonly used in the industry, using that to evaluate the TV ad effectiveness, oftentimes it will result in consistent estimate of the TV ad effectiveness. And we also find that TV advertising increases browsing and sales instantaneously, but decreases both measures during times when there is no ad. We find the immediate increase in value of sales is larger than in the number of transactions because of potential shifts in consumers' promotion usage and the potential shift in the customer mix. So what are some implications for the managers? The first implication is the natural attribution window is not sufficient. For a single company, still, like even when they have granular online data can be linked to offline TV advertising data, exogenous variation in advertising exposure is still necessary. And the second implication is we would encourage advertisers to run some like large-scale field tests for like video advertising on digital streaming platforms. And that context is more prevalent nowadays, and it is a good context to study this kind of intertemporal substitution effect. And the third implication is we do see that the TV advertising effect on the total sales and the total sessions differ between the two. And also the value of sales and the number of transactions also has different elasticity to respond to the TV advertising, which suggests that when we look at the TV effectiveness, the advertisers may want to use multiple metrics to fully understand the implication of TV advertising. And lastly, we encourage the advertisers to consider the TV advertising effect more broadly when it comes to the consumer behavior. For example, in terms of how they use the price promotions and how does the whole consumer mix change because of the TV advertising. Okay, thank you so much for taking the time to attend the talk. I like any comments or suggestions are most welcome. Thank you very much. So now I will move it to Dash, who is the discussant of the paper. Thank you.
So everyone, can you see my screen and hear me?
Yes, we can.
Yes.
See
you can see the screen? Okay,
yes,
good. Thank you. So first of all, thanks to Nanda and all the organizers of the conference for inviting me to discuss the paper. And thanks to all of you for attending this session and prioritizing this among the busy weekend schedule. First, it is my pleasure to comment on this nice paper because I personally loved reading the paper because it's related to some of the research that I have undertaken in the past. And I personally find it interesting mainly because the results relating to advertising are having its own interesting contributions to the literature. And it's going to have strong contribution, especially with respect to some of the numbers that's shown for the intertemporal substitution effects that's there. And I really appreciate those parts. So what I'm going to do now is I'll just walk you through the paper a little bit, which means I present a big picture summary of the paper so that we can appreciate the author's effort that they have put, and also understand some of the minute concepts which are interesting from my opinion. Then I would like to talk a little bit about the finding and the contributions. As I walk through the findings, I have attempted to provide some suggestions that could help the authors possibly improve the paper. It's not so much as a critique. I'm sure that the authors would be dealing that when they're going through the review process. I'm hoping that some of the suggestions that I'm making could help the authors push the paper forward and make it more interesting. So what are the strengths of this paper? So what I find it really appealing is that there are a couple of questions that the authors have asked, which are very difficult questions. So the authors have asked questions relating to advertising effectiveness of offline TV advertising on online consumer behavior and response. Now, this in itself is a big challenge. Why? Because of the nature that you're looking at offline and online interactions, which is very difficult in itself. And there's been a large amount of literature in the recent times, but almost all of them would have faced problems and hurdles relating primarily to the indigeneity issues. And also the authors here have taken one more bigger step, which is going to be assessing the intertemporal substitution effects. Now that is also plagued with lots of problems, though there's literature in promotion as well as pricing, which has shown some of these effects. But in advertising, it's a very difficult challenge to show this intertemporal effects, mainly because it is difficult to disentangle the carryover effects and the substitution effects clearly. And the authors have taken this as a challenge, and they have actually taken this in the centerpiece of this particular paper. Now, what led them to actually conclude all this was that they have rich data. The company that they use for conducting the field test, which is in 2015, one of the regions of the country it advertised on TV through a large TV broadcasting network, and others in other counties, there was no advertising going on. Now this helped them actually disentangle some of the effects that they are finding. And also the advertising is relevant. It's in a relevant industry because if you're looking at online advertising also, hotel bookings are very relevant because the consumer responses in this particular industry, it is very strong. And the setting is very appropriate for this question. Now, what are the strengths of this paper? Now, the main strength of this paper also is derived from the multiple methods and the robustness check that the authors have undertaken. So the authors undertake definitive strategy where the treatment period versus the pre-treatment period, they compare between the advertising regions and the control regions. And they also use the synthetic control method where they create a synthetic region as a weighted average of the control regions weighted by the characteristics of the variables during the pre-treatment period. Same thing for the broader strategy where they compare people living close to the border of the TV region and on the other side of that. Then they compare on some of the unobserved characteristics. This helps them to disentangle a lot of commonly encountered problems in this research. And the authors have diligently, they have worked through and checked some of the assumptions, the endogeneity concerns, and also they have covered a lot of grounds in the findings. Now I'll go through some of the main findings of the paper in brief. So some of the main findings for this paper is, first one, it's a common finding in most of the papers that's there. So I'll not call it the most interesting finding, but still it's a very important finding that leads to rest of the important finding that's there. The first one is the browsing behavior and the sales increase within the 30 minutes window is clearly seen and it's having a significant impact. But the more interesting aspect for me was the intertemporal substitution effect, where they see the spike in online activity that comes at the cost of less browsing and lower sales at times when no TV ad is aired, even in the treatment region. And also they extend this analysis to find out what is the underlying cost, which is the value per transaction. They found it to be more pronounced than the number of transactions that was made. Now they did a lot of robustness check, as Zhang was showing. There's a lot of checks that they are done, and each of them leads to some of the interesting findings that's there. The TV advertising also mitigates the negative effects of intertemporal substitution effect to an extent, and this one is a strong finding that I find personally appealing. That is, the TV advertising shift consumers away from visiting price or promotion focused web pages to focus on broader product offerings, which is kind of counterintuitive in this particular scenario, especially in travel industry. Consumers are more likely to purchase at a higher price, which is kind of interesting to me, mainly because of the setting that's there and also the way in which the authors have analyzed this. Now let me go through some of the findings, and here, as I'm going through the findings, I'll also give some suggestions that could probably help authors. Now I know that the authors, they have taken a lot of pain in going through a lot of different analysis, and the paper is already long, but still some of these are minor, or some of them are minor in extensions, which can help them in at least positioning the paper or thinking the paper from a different perspective. So first, finding that the browsing behavior and the sales increase within the 30 minutes window, they show the immediate effects of elasticity, which means it's having a 0.025 with lag or 0.035 without the lags. Same thing for effect on sales, which is even much higher than the browsing sessions. Now here, if I'm looking at it, the authors could probably compare this with the advertising elasticity that has been historically found in the literature over the past 30-40 years. So most of the literature and the meta-analysis around this area points that the advertising elasticity typically is around 0.10 or 0.11. And now here we are finding that this is close to that, at least the sales elasticity is close to that. But if you're looking at the browsing, it's lower. Now there are some reasonings that the authors have given in the paper, but the authors could go delve a little more into this and then give some more strong reasoning around this. The paper used most of the papers in the past have used scanner panel data, which is mostly consumer product, which is going to be CPG products. While this is a hotel booking, which is a high involvement product, and the authors have highlighted this in the paper. But I think that some more comments on the elasticity figures, its economic comparison, and writing more on the implication of this would help readers appreciate this particular results as such. For example, there's a footnote where they've done nice calculation on what is the impact of elasticity and what is the economic results, but I think they can move it to the main text also in some cases. where they can actually highlight what is the managerial implication. And then in the later part, when they are discussing the paper or discussing the implications for managers, they can highlight these in that particular section. It will help them actually bolster or strengthen the overall impact of this paper for practitioners. Now coming to the core of the paper, which is on intertemporal substitution. The main finding is that they have a negative alpha, which suggests intertemporal substitution. And the implication is if the advertising accelerates the demand, the substitution may lead to negative impact on the future demand. Now they control for all the carryover effects in different ways. And the spike in online activity is that comes at the cost of less borrowing and browsing and lowest sales at the time when no TV is aired as such. And this is the finding that's there. And they find that using coefficients. Now the coefficients that they used were simple coefficients in the beginning. And they also did some elasticity analysis around this. Now, my suggestion in some of them is going to be relating to the magnitude of the elasticity of substitution, which could add some more insights. Now, here, if I'm putting this in the purview of looking at only the coefficients, it is a little difficult for us to compare coefficients with the elasticity figures. It'll be easier if you're analyzing this as the rate of substitution, which is common in the intertemporal substitution literature, and then see what is the comparison with the elasticity of advertising. That would lend more clarity in the nature of the substitution effect. Where it will be very interesting is you can differentiate between the carryover effects, which means the wear in and the wear out of advertising. You can actually see that. And also, if you want to extend this, you can extend it simply by adding alternate specifications of carryover models, which has been popular in advertising. Say, for example, distributed lag models or a COIC model or something like that, and then tease out the effects and then compare these elasticities. Now, once we compare these elasticities and prove something around this intertemporal substitution elasticity and make a comparison, I think it will be a much stronger one. And also the caveat, some of them we have to take into consideration is definitely they are focused that on the paper is the effect is only few minutes to hours and the sampling is a short period of only 6 weeks. So that is a caveat, but in spite of that, I think that these analysis would help authors actually make the paper stronger. And then the second finding, I'm not going to go through the findings in the interest of time. What I'm going to do is I'll just jump into the suggestions. Here, the authors have actually talked about a lot of different explanations for the effects that they are finding out, where they are seeing that the effect is the value per transaction is more pronounced on the number of transactions made. Here, I'll urge the authors actually to compare the price elasticity, which has been found to be negative 1.6 in the literature always. When the comparison is done with advertising, the median price elasticity, if I make a rough calculation, is 15 times that of the advertising elasticity from what we are finding also here. So in that case, what would be helpful is position this finding with respect to the price elasticity also, which can help actually talk about the last point where they are trying to talk about the consumers moving away from promotion-focused web pages to focus on broader product offerings. Because if we are comparing this with the price elasticity paper, it would give you another avenue to claim contribution, which you already have done in the paper. So all you have to do is extend that right up there. And then the further, just a few comments I'll make quickly. So some of the other extension is what is the persistence of the effect? So you can talk about that. Mechanism, give a little more intuition because of the main reason that the carryover effects of advertising has to be teased out and really said that this is a substitution effect and not just a carryover effect. What I mean is the consumers usually the substitution effects will be consumer postponing the decision of the consumer response or making the choice to a later time frame. Whereas if I'm looking at the carryover effects as such, the consumers might not be even thinking of booking at that particular time, but they're just thinking of it later because of the accumulated effects of advertising that's there. Now that's a question that might come up. It's very difficult to tease it out. I don't have a strategy from the paper as such, but if it is doable and the authors can think of some strategy to do it, that's also something that could be a very good contribution. And the last one, consumer heterogeneity, though I wrote it, I find that the authors have added the analysis in this version when I was looking at the slides. So I don't want to go about it or talk about it much when the authors have already addressed this in the slides. It was not there in the paper when I was looking. The last one is the caveats and the generalization from 14-15 to 21. Some things have changed. So the consumer behavior from moving from laptops or desktops to cell phones and tablets, that one could be given as a caveat or a limitation of the paper. Also, the hotel industry in Europe is very different from that in US and other regions of the world. So some authors could provide some caveats and pointers towards this, especially given the statistics that 41% come from affiliate marketing and 15% are direct visits. So they could point something towards that. And rest of them are minor suggestion on exposition, where they can explain a little more on the details of implementation of the border strategy and the synthetic control. And there are some minor errors which are there. Errors in the sense it is minor typos, I think, where the authors could check that up. But one thing I'll like to do is definitely change all the percentages into elasticity in simple terms, because that's easier to compare and across the entire paper. Because in some places it's percentages and some places it's elasticity in numbers. So that one becomes easier to compare across it. These are minor issues, but still I wanted to just clarify that to make it a better reading, that's all. I wish the authors good luck. And if you have any questions, you can reach out to me. Thank you
so much, Sash. It's great. It's very helpful comments. Thank you.
Hi, Artem.
All right. Hey.
Can you share the
How
slide?
can I share my screen here?
Yeah. You can share your slides or your screen.
Oh, I see. Mm-hmm. Can you see it?
Yes, we can. Thank you.
Perfect. Well, I think it's about time to start the session, right?
Yeah, you can
the previous
start
session just ended on time.
yeah.
All right. Thank you very much, everyone, for joining our session today on this Saturday afternoon. Frankly, our team works with many different companies on targeting and personalization projects. And whenever we talk about this research to the practitioners, they feel really excited and they find these findings very relevant to their practice. But for us, it is the first extended academic presentation of this paper. So I'm really excited to hear your feedback and your suggestions. So my name is Artem Timoshenko. I'm an assistant professor of marketing at Kellogg School of Management. This is a joint work with Marat Ibragimov and Duncan Simester from MIT Marketing, and Jonathan Parker and Antoinette Schoar from MIT Finance. So I'll be talking about targeting for the direct mail promotions. You probably have seen many of the examples of direct mail promotions like that, especially if you live in the US. Different companies from actually very different industries send postcards, letters, or catalogs to the customers. Usually this is linked to the particular event. Say in this example, Newman Marcus, which is a luxury fashion retailer, wanted to send a promotion, a coupon for 20% off for the Mother's Day event. And so these promotions typically contain some kind of financial incentives, and they're sent to different customers by the firms. We have this general intuition, and also firms follow this logic, that we don't want to send this type of promotions to all the customers in the customer base. Instead, we want to choose customers based on their responsiveness. So if you send it to everyone, what would happen is that, well, some customers just never open these direct mail campaigns, they never respond to that. So you would just throw this promotion into the trash and you just don't even read it, so no response. We don't want to make, we don't want to spend our printing and distribution costs on this type of customers. On the other hand, it often happens that customers would purchase products anyway, so we don't want to send the financial incentives to these customers also. And so companies would rely on the targeting models to segment customers based on responsiveness, to allocate marketing actions more efficiently. So targeting models look at the customers and want to decide, who should receive the promotion, who shouldn't receive the promotion, based on whether the incremental effect of the promotion is larger than the mailing cost. There are different ways to design the targeting models. Probably the most simple way, conceptually simplest approach, would be to use the plugin estimators. So the plugin estimators, the approach would be that you conduct an experiment. Some customers, a random subsample receives the treatment, the promotion, and some customers, again, the random subsample don't receive a promotion. And then we calibrate a model which predicts what would happen to the customer with a promotion and without a promotion. So this predictive model would input customer characteristics such as demographics and purchasing behavior, and then output two predictions: what would happen with a promotion and without a promotion for this particular customer. Then the targeting model assigns whatever action yields the higher predicted outcome. There are different ways to approach this modeling problem. We might think of causal forest, treatment effect projections, plugin estimators. We might also think of some policy estimators. But what is common in all of them is that all these methods are trying to segment the customer base based on responsiveness. And responsiveness is the causal measure, right? We want to understand what would happen to the customer with a promotion versus without a promotion. Because it is a causal measure, it's a gold standard to apply these techniques and train these techniques using the experimental data. And so the experimental data often becomes a bottleneck in the applications of the targeting models. This is a very typical relationship which we observe in many companies in different domains, and it's pretty much irrespective of the method for the targeting which you use. So on the horizontal axis here is the size of the training data, the size of the experiment you use to calibrate the targeting model. On the vertical axis is the improvement of the targeting model over the random baseline. So obviously what we can see here is that, well, larger training data allows us to train better targeting models. But what we can also notice is that in this case, the company required at least 60,000 customers to actually just outperform the random baseline. And 60,000 customers is quite a lot of customers for the direct mail campaign. Not many companies have an ability to do this type of experiments, sufficiently large experiments. And even if they do that, I mean, in most cases, they cannot really increase the size of the experiments. They don't have it's not feasible, or it might be too expensive. And so the question which we have in this paper is, can we design better targeting models given the experiments we have? So for a given size of the experiments, how can we improve the targeting model? The key idea in our research is that firms often have a database of the experiments they run in the past for different marketing campaigns. And so we want to use information from different marketing campaigns to improve targeting in the focal problem. Let me give you an example. So let's think again that a company, a luxury fashion retailer, wants to optimize allocation of the coupon discount of the direct mail campaign for the Mother's Day promotion. And so if they do it this year, 2021, then typically the traditional approach would be that the company uses either a small pilot or maybe data from the last year for the same campaign for the Mother's Day event as a training data for the targeting models. So what we propose in the paper is that other campaigns, say the Valentine's event or Christmas gift cards, can be very helpful for the company to design better targeting policies. So throughout the presentation, whenever I will be talking about the focal campaign, think of this as this example, the Mother's Day campaign in 2021. We want to design this campaign. And I will be referring to different other campaigns conducted in the past as source campaigns. When we initially thought about this project, actually we thought about this paper being a simple empirical paper where we just have a huge database of different campaigns and see how different campaigns can be more or less helpful for this transferring information. As usually didn't work this way. It appeared to be that combining campaigns into the single targeted model is actually quite challenging. And there are two primary challenges about it. So the first challenge is that we often have many past campaigns and limited focal data. So in the example which I gave you about the Mother's Day campaign in 2021, the luxury fashion retailer, which we worked with, actually had over 200 experiments for different marketing campaigns ran in the last 2 or 3 years, over 200 experiments. And so you might think that some of these experiments are more relevant for optimizing the focal campaign, and some of these experiments are less relevant. So for example, if you think about this Mother's Day event in 2021, probably Mother's Day event in 2020 or 2019 would be very relevant and will help us optimize the targeting model. On the other hand, some campaigns were designed for different target audiences, for example, the Father's Day event, or those campaigns had no financial incentive. So here we want to send a 20% discount, but say for Christmas there was just a general postcard without any financial incentives. So we clearly see that some of these 200 campaigns will be very relevant for optimizing targeting models, and some of these campaigns will be very irrelevant. And so when we try to incorporate all this information in designing the targeting model for the focal campaign, we might introduce lots of noise. And given limited data in the focal problem, given the limited experiment for the Mother's Day event, we might just undermine the performance of the targeting model instead of improving it. So this calls for some kind of regularization, which will be very important in this paper. The second challenge which we face in this problem is that, well, computer science research, the transfer learning literature, and marketing research have a lot of tradition, have a rich tradition of combining different data sets to improve predictions. And improving predictions, unfortunately, does not necessarily translate into improved targeting policies. So we had to come up with a method which would help us to combine these different data sets and improve the final targeting policy. And that was kind of the essence of the paper. That would be something which I will be talking about in the next few slides. But let me pause here for a second for questions about, do you have any questions about motivation or the challenges which we face? I'm sorry, guys, I just don't see any faces. So if some of you could turn on the videos, that would be very helpful. And hey, you can unmute yourself to ask questions. Yeah, hey, Venkat.
Hey, Artem, let me ask you a question since you want engagement and we are going up next. But anyway, I really love the problem that you're studying. But one of the challenges is that as you incorporate data from the past, you've already endogenized many of these decisions in the past, and you are basically having data that are not completely random. So aren't you compounding some of the errors that may have been made and the response to that when you are trying to target again? Just a conceptual question. Thank you.
Right. So I think this is an interesting question. In this paper, we constrain ourselves only to using experiments done by the firms in the past. So the firm which we were working with, they had 200 different campaigns, and for all those campaigns, they conducted A/B experiments. So we kind of stay away from the challenge you mentioned. In general, there are methods for designing targeting policies which would use observational data. And in those cases, I would expect that your concern is very relevant. In this paper, we just stay away from that because we use experimental data.
Good, thank you.
All right, let me keep going. So conceptually, why we might expect that it works and why we wanted it to work is that we expected that responsiveness to marketing promotions by the firm can be somehow transferable between different campaigns. So if the person sometimes responds to direct mail campaigns, maybe different campaigns, we expect that this person would also be more likely to respond to the campaign we want to target right now. And so because we want to transfer information about responsiveness, in our solution, in the proposed method, we use targeting policies designed for different source targeting problems as a summary statistic, which we transfer between domains. So instead of just simply using data sets from different source targeting problems, from different source targeting campaigns, we'll use the source targeting policies, the policies already trained for, say, to target Christmas gift cards or target promotions for the Father's Day. We'll use these policies as summary statistics of the past data sets. And then the approach proceeds in two steps. Basically, in the first step, we pre-select which source targeting policies are more relevant for the focal problem. And then in the second step, we will combine the source policy and the focal targeting policy, which is trained without any transferring information, just using the focal experiment. So we'll combine the pre-selected source policies and the focal targeting policy into the targeting policy, the final targeting policy, which hopefully improves the outcomes. The key idea for both of those steps will leverage the concept which we call the direct transfer value. And so this is very important. So let me spend a little more time on this construct. Basically, it's a very insightful idea coming from the 50s in the statistics literature. And the idea is that if you have a simple experiment where you randomize customers in the treatment and control conditions, you can evaluate performance of any targeting policy without running additional experiments. To give you a simplest example how it can be done, basically, suppose you have 1,000 customers, and for these 1,000 customers, for every customer, your targeting policy recommends 0 or 1, mail or no mail, for every customer. And then you have a 50-50 randomized experiment where you randomly assign customers into treatment and control. So out of your 1,000 customers with policy recommendations, you will have about 50% of the sample where the recommendation by the targeting policy matches the experimental assignment. And this 50% of the sample, these 500 customers, are randomly sampled from the population. So if you just take the average performance for these customers, you would see how, on average, this targeting policy performs in the entire population. So this is called the Horace-Thompson estimator. It was initially proposed for the survey analysis. But this is a very powerful idea which can be applied to targeting models. And this is sort of recently recognized by marketing literature too. And so the idea which we use in the paper is the following. We can take the source targeting policies, the targeting policies trained for different campaigns, and evaluate how they would perform in the focal domain. For example, you might have designed a targeting policy to send Christmas gift cards. So some customers would be assigned to receive the Christmas gift cards, and some customers don't receive the Christmas gift cards. So now, instead of Christmas gift cards, we imagine that this policy does the mail or no mail decision, just the same it was doing for the Christmas gift cards. But we say that the policy does no mail and mail decisions for the Mother's Day coupons. And because we have the experiment for the Mother's Day coupon in the past, we can evaluate how well this policy performs without any transformations for sending these Mother's Day coupons. So the policy was initially designed to target Christmas gift cards, but we evaluate how it would perform if instead of Christmas gift cards, it just mailed the Mother's Day coupons. So we call this performance of this policy the direct transfer value, and that becomes a very important construct in the method we propose. Basically, if we see that the source targeting policy yields the high direct transfer value, then we assume that this policy is a very relevant source of information for improving the focal campaign. This basically creates us a single score of relevance of the source data sets to the focal data set. To give you some time with this idea, I can contrast this direct transfer value idea to the more traditional approach for choosing the source problems. So traditionally, we might think about choosing the source problems by using different attributes of the campaigns. For example, if you want to target Mother's Day coupons in 2021, we might think that the same campaign, Mother's Day coupons, in 2020 would provide a more relevant source of information that the same campaign sent like 5 years ago. So recency becomes an important attribute. Then we might also expect that coupons for the Mother's Day from the last year would be more relevant than Christmas gift cards from the last year, etc., etc. So there are many different dimensions which you could consider to identify similarity between source data sets and focal data set. And so combining these different dimensions into a single score might be a challenge. And so our solution to this problem is by using the direct transfer value. So we train a policy on the source data set and apply it directly without any transformation to the focal data set. The direct transfer value, by providing this relevant score of the data, allows us to pre-select only those targeting policies which are most relevant and which provide the most signal for optimizing the focal problem. So once we pre-selected the source campaigns, we want to combine them into a single policy. This slide basically outlines how we combine, but let me guide you through 3 basic principles here. So basically, all campaigns which were pre-selected recommend 0 or 1, no mail or mail for every customer. And so now when we combine it, we basically consider just a weighted combination of these recommendations, 0s and 1s. And if the weighted score is greater than 0.5, then we mail. If the weighted score is below 0.5, we don't mail. We choose the weights in this combination to maximize the performance of the targeting policy in sample. So we basically use the same Horowitz-Thompson estimator, which I described a few slides ago, to choose the weights of this estimator. And additionally, we introduce a little more regularization in the method. And basically, we make the weights proportional to the direct transfer value of the corresponding policies. So if the source policy yields higher direct transfer value when applied to the focal problem, we assign it a higher weight in the combination. So this is kind of an overview of the technical side of the paper. But to summarize, we really were trying to address this key challenge of how we can combine multiple past campaigns, some of which are relevant, some of which are irrelevant, into a single targeting policy so that we regularize, filter out noise, and be able to identify what is the informative signal there. And so the regularization approach which we propose in the paper is based on the direct transfer values. And the direct transfer values help us to identify relevant campaigns. And then once we identify the relevant campaigns, direct transfer values allow us to combine these campaigns using just a single parameter, which is encoded in these weights. Any questions about methodology before I go to the evaluation? All set? All right. So we apply the proposed method to the data set from the luxury fashion retailer. Similar to the very first slides, on the horizontal axis here, you can see the size of the training data or the size of the experiment which we had for the focal problem. On the vertical axis, you see the performance of the targeting policies. We see that for all different sizes of the training sample, the transferring information between campaigns helps to improve targeting policy, well, except for these numbers at the beginning, for very small training samples. So we can read this plot vertically, which is for a given data set, for a given focal size, for the given focal experiment, we can improve the performance of the targeting policy by transferring information between campaigns. We can also read it horizontally, and we see that for some of the data samples, we might train the targeting policy, which yields the same performance, the same profit outcomes, with twice smaller, with a half of the training sample. The horizontal axis here is the log scale, so don't be surprised. This is like 50%. This is a very substantial improvement. It's also interesting to look into this plot as a difference between these two curves. So horizontal axis here again is the size of the training sample, the size of the experiment. Vertical is the difference in performance, basically how much value transferring information brings to the table. And what we can see here is that for the small values, the performance improvements are small or even negative. For the large values, the performance improvements are small again. And so the primary gains of transferring information happen somewhere in the middle. And that very nicely just reinforces the ideas we had when designing the methods. Basically, when you have very small samples of the focal data and you try to combine multiple source data sets, you face this risk of introducing the relevant and irrelevant data, and you just cannot filter out the noise. You cannot understand what is the informative signal in the source campaigns. You just don't have enough data for that. So performance of the targeting policies can get actually worse with the small focal campaigns when you're trying to incorporate all these different data sets. On the other end of the spectrum, for very large campaigns, so when we have large experiments, the focal campaign itself, without any transferring information, is already good enough. So there is really no much room for improvement. And we see that the gains at the right end of the spectrum is not particularly large. The main benefits are coming in the middle when the data sets for the focal campaign are neither too large nor too small. We replicated this analysis in two additional settings. We replicated it in the membership wholesale club and the very large financial services firm in the US. In both of those cases, so in all three applications and all three firms, we see that transferring information between marketing campaigns can be very helpful. It substantially improves the targeting policies. What is really important here and very notable is that all these different applications were different on different dimensions. So we're talking about different industries, we're talking about different goals of the campaigns. So the target audience could be new customers versus upselling to the existing customers. We are talking about different marketing channels, different size of the treatment effect. So the applications were different on multiple dimensions, and still with the proposed approach worked and produced very great results. In summary, I wanted to say, so we work with many firms on targeting and personalization projects, and we see that experiments often become a bottleneck. Firms just, maybe larger experiments, firms wanted to run larger experiments to train better targeting models, but larger experiments can be costly or not feasible. And so transferring information between marketing campaigns can help us design better targeting policies, which is very valuable for these applications. In general, this relates to an interesting topic of how we can transfer information between marketing domains and improve marketing decisions. We see that many firms accumulate this databases of past experiments in different marketing channels for different marketing messages. And so it's really interesting how we can leverage this information between decisions to improve the focal decisions. In our paper, we show that targeting policies could be improved by transferring information between problems, but I'm sure there will be some interesting research which would help us to improve marketing decisions in other domains. So let me stop here. We'll have more time for discussion and then questions, probably after discussion.
Thank you, Artem. Yeah, I'm the discussant of this paper. Since we have a lot of time, so I start the discussion and then stop me anytime. We can chat. And if anyone wants to interrupt, everyone is welcome to join the discussion. Okay. Let me see if I can share the screen. By the way, Microsoft Meeting is the team is eating my CPU somehow. So if something happens, it's because my PC died.
Yeah, it's
okay.
Yeah. So David, It's on top, after video, mute, and then there is share content.
Okay, yes.
Hey, Duncan.
Oh man, okay, wait a second. Because I cannot share apparently. Why?
Yeah, we can see it now.
Did you see? Can you see?
Yeah, we can see your slide now. Yes.
Okay, I see the slide. I don't see you guys. Where are you now? I cannot see.
Yeah,
you.
I was also struggling with that. I couldn't see any face, any video really.
Okay, okay. I guess it's okay. Okay, first let me thank the conference organizers. I really miss being in Dallas. I've been there for the past 4 years, and this year is an unfortunate year. I actually last year conference was my last conference of the year. After I came home, they closed everything. So let me start with discussing the paper. Let's start with a little bit of background. So how do I move this? Okay, so we are talking about targeting in marketing, very popular topic, many ways to do so. And the settings of the paper is basically something like this. Think about a direct mail marketing campaign. The firm has two actions. You can mail or no mail the users. We have J customers, each one with XI characteristics. And each one of these customers generate some profit under action 0 or action 1, which is mail or no mail. And the goal is basically what? Maximizing the profit using a targeting policy to decide which consumer to send a mail and which consumer not sending a mail based on their characteristics. Okay. What's the standard way to do so? We create some training data by running a A/B test. And then we use a predictive model to predict the outcome. And then the policy will decide which consumer will receive the email and which consumer won't. Again, with the goal of maximizing profits. Okay, that's the background, very simple. What is the problem? As Artem discussed before, the problem is that the firms face a trade-off. Large experiments lead to better targeting data, targeting policies, but they are also costly. Okay, sending emails, buying ads. These are all actions that cost money, and we know in general that A/B testing with firms leave a lot of money on the table without getting too much results. And actually, as the figure that Artem shows and the figure that you can see on these slides, performance improves drastically as the size of the experiment increases. Okay. So, what's the research question and contribution? Can we basically, very simple, can we improve the policy performance without increasing the size of the experiment? Right. Can we do this? The answer is yes. If you use additional information, which is free from past policies. Moreover, and interestingly, these policies do not necessarily need to be too similar, and the paper will provide a method to identify such policies. Okay, this is the main question and contribution. There are a couple of insights that I want to discuss. Insights about policy transfers. It is okay to transfer either average treatment effects or conditional average treatment effects. However, in this case, you need the original data used to train the policy to transfer, which is probably not always possible. And indeed, the paper focus on the second case in which what they transfer are marketing actions, or in other words, the policy, what the consumer is gonna under which condition the consumer is going to be, whether receiving the email or no email in the case of the example of the beginning of this discussion. And in this case, the advantage is that we don't need the original data. We just need what is the action that was assigned to past consumers. So, which is great, right? And also, I think Artem mentioned this, but it is not ideal to transfer predicted outcomes. Why? Because in this case, the info of these outcomes is likely not to be too relevant to the current policy. Okay, so the focus of the paper is on the two options above, with a particular focus for the example on transferring the policy. Okay. So, second insight: how can we choose policies to transfer? Again, very intuitive. Direct transfer value, basically apply the policy to be transferred to the focal data. and see how it does. If it does well, it's probably going to be a good candidate. If it doesn't do so well, it is probably not going to be such a good candidate. Okay. Okay, this is basically a description of the paper in a very high level. Let me tell you the results. As you also see in the Artem presentation, on your left you'll see the difference between using data from the focal policy only and the transfer policy. The transfer policy does on average better, even with small amount of data. It cannot be too small. And it can be large, but when it's large, the difference is not too much. To see this, you can compute the differences between these two curves, and you clearly see a U shape, right? Basically, the optimal amount of data to use when you transfer policy is more or less in the middle of the distribution. And as I mentioned, transfer policy works very well with enough focal data, but not too much. When focal data is too small, there is not enough information to identify which part of the transfer policy is relevant to the focal one. And when the data is too large, the focal policy can already do well enough. Okay. I think there is a lot to like about this paper. Honestly, it's a very simple paper. As most of Artem paper, I think, you know, I've known Artem for a long time now. I know his papers quite well. They are always clean and simple. I think this idea is very easily to implement. Likely to be extremely flexible. That can be adapted to different use cases. In the paper, they focus on a binary policy, but I think extension to more options, it shouldn't be too complicated. And also, they test this algorithm under 3 different firms and domains, and show that, you know, this transfer policy works in any settings. It's not really domain specific, it's not firm specific. Results are consistent across the 3 firms that they study. So I think overall, again, I like a lot this paper, and it actually took me a long time to think about limitation and potential suggestion, but let me, and I'm going to be maybe a little bit nitpick, but you know, it's just because I wanted to try to tell you something that may be useful for the future. Limitation, I think Artem discussed a couple, but let's think about it a little bit. The set of users to transfer the policy and the focal policy must be the same, or there should be a large overlap, I think. And this might be a limitation that maybe for new firms in which the consumers are growing, firms that are growing fast, therefore they have a lot of new consumers. And it is definitely a limitation, I think, for policies aimed at acquiring new customers. And I think Artem mentioned this in the paper. I was also thinking about how old can be the policy. I think in my mind, I think they cannot be too old, in the sense that if you're trying to maximize profit despite not predicting transferring the outcome, if the decision of consumer are very tight to the to the prices of the product or to the type of products that the firm is selling at a specific time, then I think this could affect the value of the transferring past policies. And finally, and this is also mentioned in the paper, you cannot really combine too many policies without the risk of overfitting. Why? Because the goal here is to use a small amount of training data, right? So if the amount of training data is small, and you use too many policies, you're going to be probably going to overfit, okay? These are the limitations I found, nothing too terrible. I think this makes sense. And let me try to give you a couple of suggestions. I was thinking first about reinforcement learning, right? I don't think you discussed this in the paper or in the presentation, but we all know as marketers, you know, people that run experiments, that A/B test, leave money on the table. So in the past few years, we moved away from simple A/B testings and do what we know, what are called, you know, bandits, right? Why? Because they can optimize A/B test, reduce the amount of data, and produce results that are still good. And I was wondering if it is possible that by favoring this exploitation versus exploration, you know, you can obtain training data that is better training data, which means that then you need a small amount of training data to get a policy to work quite well. So maybe there some comparison. I think I would have liked to see maybe a discussion about this issue, whether I'm completely wrong or not. You know, maybe this could be, I think, some insights for the readers. And the second point is about so how firms are going to implement this, right? You're telling the firms that the behavior of your algorithm is U-shaped in the performance outcome, meaning that you have a bound below and above, right? You have a minimum number of minimum size of the training data that you need, and that to get positive improvement, and also you have a maximum amount of data beyond which the improvement is not much, right? So it's not really worth it. So I guess my question is, you know, can you say something about the amount of data needed for transfer policy to work, or in other words, how can firms pick the optimal training data size, right? Ideally, if you look at about these pictures, I guess the firms would like to pick something between 50 and 80,000 customers for focal training. Going above doesn't make much sense, going below doesn't either. But it seems that at this point, the only way to infer this kind of bounds and the size of the data seems to do experiments, which at the end is going to be costly, right? So I was thinking how this is going to be implemented in reality. And I think that's everything I had to tell you about the paper. Again, great paper, very simple. I'm sure it's going to do well, and we'll see it published very soon. And happy to chat more about it.
Well, thank you very much, Davide, for a great discussion. Your summary was just on point. Thank you. I really like the two limitations you described. So the first one about multi-armed bandits, I kind of have two thoughts about it. One is, well, multi-armed bandits are definitely very helpful in many digital settings. But what we see is that, say, in the direct mail promotions, it's really hard to implement the multi-armed bandits and the online experimentation in general. I mean, companies have this operational constraint that they have to design these promotions like the postcards, print them, send them to mailing. It's a long process. So online experimentation often less applicable to the direct mail promotions. That's why, in particular, we sort of frame the paper more around it. But in general, I think it's a really, I think it's a really great idea to sort of think about how these past campaigns could help in the multi-armed bandit settings. I think there are some opportunities, maybe some kind of priors. They could define the priors for the multi-armed bandit algorithms. I'm not sure, but I think it's a really interesting question. Might be the next challenge actually to target.
Yeah.
I really agree with this extension. Then you had a very interesting point about the training data size. So reviewers also picked up this point. And I think it's the way the paper is written in such a way that we sort of provoke this question ourselves. But in fact, we were kind of thinking about this problem from the perspective of, well, we have what we have. You know, the experiment is given. So how we can design the best targeting policy? And to some extent, our characterization of these bounds is more of just limitations of the methods rather than sort of trying to find the optimal point of the experiment.
Yeah.
I generally find it interesting that, you know, in general, when we think about this sort of size of the training data, it's so campaign specific. So the curve which you saw, and like the one that I shown on the slide, it was 60,000 customers to achieve statistical significance over random policy. But it really depends on the promotion. Sometimes it's 20,000, sometimes it's 500,000 is not enough. So it's really hard to come up with good characterization. You have to make some assumptions about, you know, how the size of the experiment translates into performance of the targeting. So it should be some kind of parametric forms on learning rates. And now I'm just completely, it creates complete mess. I don't know how to approach this problem.
No, again, and I'm pretty sure that most of these bounds are domain specific. It was just, you know, a question I had in mind, and I said, let's ask him. I'm sure you thought about it. I mean, but again,
yeah, but honestly, right now we are working on rewriting this paper. And this is one of the concerns we want to address. this is something which is very important. I agree with you. Thank you. This was a great discussion.
Oh, thank you again for the invitation, guys. Always happy to be here. Hopefully in Dallas next year.
Yeah, hopefully.
Yeah.
All right, I think we have more time for questions. If you guys want to ask more questions, we'll be available here. I will also be very happy to receive any emails with feedback and suggestions on the paper. Please feel free to reach out.
So I do have a question. Let me ask a question since we have time. So do you think that your this transfer policy is going to be much more important for how do I put it? Like for less digital actions, in the sense maybe send a catalog by mail rather than digital advertising, for example, right? Where things are much cheaper, right?
I deleted the slide from the presentation. In general, we might think about it as a sort of pyramid. Some marketing actions have very high effects, say outbound calls, very large effects, or direct mail have larger effects. But then experimentation is limited there. Experimentation is costly and usually limited. On the other hand, things like email campaigns or online advertising, they have smaller effects. And experimentation can be feasible and larger. But then again, for email, for example, it's really hard to detect average statement effect, not even talking about heterogeneous statement effects for targeting, right? So in principle, for email campaigns, we might be able to conduct larger experiments, but designing targeting policies for emails might be just impossible, even with like huge experiments.
Right.
I think that this approach might be applicable to different domains. We actually tried for open rates in emails, it improved, but it might be even more valuable for firms where the actions are more costly. Say, for example, optimizing outbound calls. Say, don't do very large experiments, but use this type of transfer learning approaches. That might be very valuable.
Right. Makes sense. Makes sense.
Hey, David, thank you very much for a nice discussion. Thank you, Artem. I have a quick question. Can you, this seems like David made the point that you have to use more recent data. And I'm thinking it also depends on responsiveness to your marketing efforts, right? And that could change based on, oh, I'm sorry, there's a static, right?
That's okay.
I don't know.
There is a little bit of echo. I think David is coming from you.
Okay.
Oh, really?
Might be.
Okay, thank you. My point is that, response to this kind of name and market products and all, it's also depend on life cycle stages. And it's also, how frequently the product is bought. For example, Costco, you'd like to see people buying regularly, whereas, in Neiman Marcus, people buy on occasions. So many of those past policy transfer, it will also be contingent on how their responsiveness will also change over the past couple of years and so on. So is there a way for you to exploit the difference between financial services, Costco, and Neiman, and see if there's a difference in transfer of learning, transfer of policies that affect? So when you plot the curves, can you see if there are some differences in there?
So we did a little bit of analysis where we tried to understand which campaigns produce high direct transfer value and general produce more value when we transfer information. And in this analysis, we were characterizing the differences between campaigns. One of the variables was actual time, the recency of the campaign. We see that on average, more recent campaigns tend to be more informative. But that's a tricky conclusion. Say, think about what happens in 2021. So luxury fashion retailers would say that things are closer to normal in 2021 because of the pandemic. They're closer to normal than they were in 2020. So in principle, we might want to, even despite 2020 campaign was more recent than 2019 or 2018, we might want to disregard this 2020 campaign, even though it was more recent. And so what I kind of we underemphasized in this paper, but I think it's a valuable point, that this direct transfer value, when we compute it, it produces the measure which doesn't require us to make assumptions about the recency or sort of same focus on the products or same subject. It just produces this one single measure which is indifferent to all those different, dimensions of differences. It was also an interesting conversation we also had with the luxury fashion retailer. There might be quite a lot of non-stationarity between the years. And so we might want to take it into account when we design the models. The current traditional approach is that you use training data from past year to design the targeting model today. But maybe a much better approach would be to run a small pilot experiment very recently. It might be a better approach. We actually have never went through to actually run this type of study. The challenge might be that, when you run a recent campaign, say you run a campaign, a pilot study, and then say a month later you run the actual campaign, is that you only observe outcomes for a month long or a few weeks, right? You just collect whatever performance you observe per customer in a few weeks. And usually you want to target based on long-term outcomes. So now you have to make assumptions about how you make a projection from short-term outcomes to long-term outcomes. So pilot studies have this advantage of having less non-stationarity, but they also have a disadvantage that now you have to make a projection from short-term to long-term outcomes. I guess that doesn't really answer your question fully, but that's at least some insights we have about it.
Okay, thanks.
Hi, can I ask a question?
Yes, please.
So is it possible to combine what your paper is doing with some kind of like a pilot experiments? So using past experiments and to use that to guide pilot experiments, and then use the pilot experiments to guide what to run field experiments. I mean, both the pilot and also your sort of source is providing extra information, right?
Right. So we kind of rely on the pilot experiment to combine the information from the past campaigns. I mean, ex ante, we don't know which of the past campaigns will be more relevant. So pilot experiments help us identify how to combine them.
I see.
I don't think we have thought about, I mean, your question also relates to the exploration-exploitation trade-off to some extent, that we can use these past campaigns to design where we allocate this experimentation for the pilot. We haven't done this analysis. I think it would be very interesting, but we don't have much results in this direction.
But then I think another way to think about it is now every experiment you run has a short-term value and it also has a potential long-term value. I mean, if you run for experiments, do we need to keep that in mind, right? I don't know how people have thought about that. So, I mean, every time you run a field experiment, you have a specific goal in mind. But I mean, with your tool, you could think about, okay, well, what can I do with this, next time, right?
Mm-hmm. Yeah, that's very interesting. I agree. I mean, the only paper which comes to mind about it would be the paper by Ron Berman about test and roll in experiments, right, where when we decide on how large the experiment we run at the first stage, because in the second stage we implement the learnings only on the finite population which was left outside of the first experiment. And so it would be interesting whether our results can be combined with his research in this direction, and whether it can guide and improve some of the statistics there.
Right, but what I mentioned is like cross time, but you could also across firms, cross section. Now suddenly, if the tool works well, then you suddenly have a lot of functionalities, not only over time series, but also cross section, right?
Yeah.
There may be a market to sell such information.
Yeah, thank you.
Hello. Okay, shall we continue with the next presentation? Okay. So, Kathleen is going to present, right?
Yes, Venkatesh is going to present first, and then I'll take over. Yeah, but I can share my slides.
All right, thank you, everyone.
Yeah, go on, share your slides. It's on the top of the screen.
Okay, can you see it right now?
Yeah, yeah.
Okay.
Yeah, we can see it. Okay.
I guess the static is gone now. Maybe it was coming from one of the speakers, right?
Yes, the static is gone.
Yeah, that's good. There's some residual static, but I guess much smaller. So Kathy, were you able to fix the animation?
Yes, I did.
Okay, all right, okay. So just for my part, we don't need any animation. For your part, you continue with your, yeah.
Yeah.
I guess we can feel the last session impact already. Right. So David, you're brave to really come the session before last and do this. Thank you. And we're even braver. But it's great to see some people are still around.
Yes, thank you for staying for the last session.
Hi, Kathy. Hi, Venki. I'm still here. Arun here.
Hi.
Hey, Arun, how are you?
Great to see you.
Good. Doing good. Good to see you.
How have you been? Arun, a long time no here. Yeah, you've been doing okay? How did you survive the storm? How did you survive the storm?
We made it. So, yeah, it was a tough week, but we're okay.
That's good. At least you're back to normal. We're all crawling back to normal, so.
Yeah, and I heard there were issues in Austin as well, right, Kathy?
Yes.
Yeah.
But
we had big time,
we're pretty
both
lucky.
in College Station. I think it was very, very spotty. You know, I had neighbors who had spared everything because they were closer to a hospital or a fire station, but we had bore the brunt of it. And Austin also, had a lot of issues.
Yeah, tough week.
Yeah, we're pretty lucky that we didn't lose power, but yeah, a lot of people lost power for.
How about you, Nanda? Did you survive without any major damages?
No. I mean, there was quite a lot of variation. I think there are some, like you said, houses near the fire station or hospitals didn't lose power, but those of us that were not that fortunate, we didn't have power for a couple of days. So, a lot of people had all kinds of damages, water leaks.
Yeah, that is the biggest. I had some refrigeration leaks, electrical repairs, all kinds of things. It's just a snowballing effect, right? Literally. Anyway, I guess people in California like David have to face fires. I guess that's a different problem to have, right?
Very different problem. No winter here, no winter.
Katie, I believe you canceled your sharing.
Yeah, let me share it again.
Yeah, you can start whenever you are ready.
So I thought I saw Sungjin, right? He's already here, right?
Hi, Venki. Hi, Katie.
Hey.
Hello. Thanks for being here.
Thanks for
Thank you,
making it, and thanks for taking the time.
Thank you.
So how is you're in Hawaii right now? Is that right?
Yeah, I'm in Hawaii.
Are you literally on the beach right now, or?
I'm at my office.
Oh, okay. Which is the same as a beach, right?
Yeah. But I'm going to go to beach after the presentation.
Thank you. It's 1 o'clock. Do you want to get started?
Yes, let's get started. Well, we need a prompt from the organizer, right? Nanda?
Yeah, go for it.
Go ahead. Okay. All right. Welcome, folks, to the last session. We are the one standing between you and your weekend. And thank you very much for the organizers for inviting us to present. Although I'll take it up with Nanda as to why he scheduled us the last session, but that's later on for some other time. But we are Kathy and I.
I'll tell you why now.
Okay. All right.
Because, we wanted some good presentations on the last day also.
Oh, okay. Come on. All right. Yeah. Thank you. But we'll see. But Kathy and I are very delighted to be presenting here. It's very ironic because last time we were in UT Dallas, we were face to face, and just after that, COVID-19 broke out. And, how would we ever have anticipated that next year we would be presenting this, but on a topic like COVID-19? But, we did, and eventually that's what we are here for. So Kathy, next slide, please. It's a very long title, but we'll try to make it manageable. Okay, Kathy, can you move to the next slide? Okay, so here, the way we want to go about it is we want to motivate our problem, which is a public health problem, but it's a marketing problem too. It is the impact of COVID-19, lifting of the lockdown of COVID-19 restrictions on the daily cases of COVID, which is really the outcome variable. And talk a little bit about contributions. Want to provide a brief overview of synthetic control methods, which is what we work on in this paper. We are developing a new inference theory, and we will outline that. Kathy will outline that, and she will present the simulations associated with that, and then go dive into the empirical application of COVID-19 management and conclude. So next slide, Kathy, please. So if you think about COVID-19, it's already caused a lot of havoc, disrupted healthcare, business, economic life in general. Everybody admits that it's a black swan event with high extreme consequences for individual firms and governments. And many policy decisions in the US, the federal government, state government, local governments, have had to issue shelter in place or stay at home or lockdown, whatever you call it, kind of policy decisions. And they have been going in and out. So even as we speak, we've seen the waves go up and down. Some states lifted those lockdowns to reopen the economy. As you know, the tension was between the economy is still between economic growth and keeping people safe. And how do we evaluate the effect of lifting of these kind of lockdown or shelter in place when it is very hard to do with the data that we have even as we speak, all right? And make the right decision moving forward. So that's the big problem that we are trying to address. And here are some screenshots that really amplify or exemplify the problem. Is this not a problem just in the US, all over the world, right? Every country is faced with this challenge of when to ease lockdown, when to really go back into lockdown. Next slide, Kathy, please. And some of the popular press articles are critical. They said that lifting of COVID-19 restrictions would be severe consequences if it's lifted too early. Next slide, please. And some, again, anecdotal evidence of popular press studies said if large wave of infections will happen if it's lifted too fast. And we needed to have the long-term policies of 2021 and beyond, right? And next slide, please. in fact, as I mentioned before, this is a dilemma between how long do we wait to lift any sanctions to reopen the economy. And the evidence is, there's a debate on both sides, which is, some say that it's not either or. You have to first wait for a long time and look after the health and then ease the economy. So it's a false trade-off, some of them say. And the next slide, please. Some of them anecdotally have come out with some lessons on lifting lockdowns, what we have learned. And next slide, please. And, the interesting thing is we have some quasi-experimental data, which is natural data. Some states have lifted the sanctions, some states have lifted the lockdowns, and some states haven't. But curiously, there are some issues in measuring whether lifting has increased or decreased or the case rate. But we know that before just the lifting, some things happened, like hours before businesses were slated to reopen in Texas. Texas registered the highest COVID-19 death case. So all these incidences, anecdotal evidences are pointing out the challenge of measuring the outcome of a policy decision when you have limited data. So our focus is on what is the causal effect of lifting a shelter-in-place order on the COVID-19 cases. Again, challenge is no randomized control design is feasible, and here's where the importance and usefulness of synthetic control method really comes into the fore. And next slide, please. And there are several marketing applications of synthetic control methods, and I'll give you a very brief overview and turn it over to Kathy for our problem. By some measures, it has been argued that synthetic control method is the most important innovation in the evaluation of policy evaluation literature in the last 15 years. At least Susan Athey and Invence's the 2016 paper talks about that. Then we all know that the more famous paper of Abadi, the review paper of Abadi 2020 gives you an overview of synthetic control methods. Briefly, very useful when you have one or more limited number of treatment units and a lot of control units, which we call multiple donor units of pool. And we have varying degrees of pre and post number of observations. It could be small, big, but all of these are very good examples where synthetic control is very useful. And we've used it to study the impact of regulations, legislations, policy interventions. Abadi et al. 2010 AER articles about the Basque Country policy interventions. We've used it in marketing, online paywalls and sales. Adi and his co-authors have studied that, and Tong and her co-authors have looked at payment disclosure on prescriptions. Seish, who was recently a discussant in one of the papers, he and Telus have a paper on advertising on word of mouth. And even Kathy and I, which we have a paper on the opening of a physical store by digital native retail, which we presented last year here in the same conference. In the two-step synthetic control method. So there's been enough evidence of applying synthetic control method. In general, it's very useful for applications such as this. And for example, you can look at other cases like opening up any physical store and sales, not just a digitally native retailer, any kind of retailer. Omnichannel could be. Also, you can look at the impact of store closure on the sales. CCPA, which is the California privacy policy on digital behavior, and what we study in this public health context is the COVID-19 mandates on economic behavior. I'm going to turn this over to Kathy, who's going to talk about our situation, and particularly she's going to be talking about our data being marketing data, and these kind of public health data is often confronted with non-stationarity in the data structure. So she's going to talk about not only non-stationary data, but non-stationary data of an unknown form. So Kathy, please take it away. Thanks.
All right, thank you so much, Venki. Yeah, so as you saw in the previous slide, Venki went over lots of different marketing applications where you might want to use a synthetic control. And what you'll notice about a lot of those data, like the dependent variable, is, for example, sales, you're going to see most likely non-stationarity in that data. And so this is a practical data problem that affects a lot of marketing research problems. And when we talk about non-stationarity, non-stationarity can take a lot of different forms. It can be linear, it can be non-linear. For example, it can be a unit root process. But in many of these cases, marketing contexts, as well as public health, medicine, other business disciplines, we face data that are non-stationary. And in practice, when we deal with this data, we do not actually know the structure of the non-stationarity. Okay, so we might not know that the non-stationarity is like linear or it follows a unit root process or something like that. And so that kind of brings us to the problem that we want to address in this paper. So it turns out that inference theory for quasi-experimental methods, such as the synthetic control, when you're dealing with non-stationary data of unknown structure, does not exist in the literature. So that brings us to the main contributions of our paper, where we developed the inference theory for quasi-experimental methods, such as the synthetic control, to estimate these causal effects of interest, such as an average treatment on the treated, the ATT, when your data are non-stationary of unknown structure. And we actually look at 3 different quasi-experimental methods: the synthetic control method, a modified version of it, and an ordinary least squares method. And we established this inference theory through theoretical proofs. And so there's actually a lot of mathematical proofs, which I will try to go over the intuition and less like the details of the proofs in this presentation. And we also verify the results of our theoretical proofs through simulations. So I'll walk through that as well. And finally, we'll circle back to the application, which is to estimate the causal effect of Texas lifting its shelter-in-place order and seeing what is the effect on COVID-19 cases. I just want to briefly go over some related literature. So this is a very exciting area to be in because the synthetic control method was developed in the last 10 years, and a lot of this literature is currently being developed in the last few years. So obviously our paper relates to the synthetic control method, relates to the OLS method, relates to the recent developments using a Bayesian synthetic control, which Sujin wrote, and the penalized synthetic control methods, as well as our 2-step synthetic control method that Venki and I also developed. In addition, our paper is also related to papers that look at inference theory in this space. And so it's related to papers that already look at, what happens if you have stationary data, or if you have non-stationary data, but you know the structure. How do you do the inference for these type of data? And it's also related to papers that use permutation tests. And so with permutation tests, this is generally what you use when you have a pretty short post-treatment time period. And there's also some kind of strong assumptions that you have to make of the distributions of the errors between the treatments and control, which can be kind of restrictive. And so we kind of view our paper as a complement to these methods, where you have perhaps like longer post-treatment time periods. And if you're really interested in more of this literature, Alberto has a really nice survey paper in the Journal of Economic Literature that kind of goes through some of these methods. The model that we use in our paper is we assume that the outcome variables are generated by a factor model. And this is a very natural way to model the dependence between the treatment and control. And here we have this FT variable, which is a non-stationary factor, and we don't assume like the known structure. So this is a non-stationary factor of unknown structure. And using this factor model type of way to model the outcome variables, we can actually cover a wide range of data generating processes. And here, I'm just showing one factor, but you can very easily generalize this to the multi-factor case, and you can refer to a corollary in the paper for that. Okay, but before we go over kind of the inference theory, which is the bulk of the paper, I just want to go through the details of the synthetic control method to make sure we're all on the same page. So again, the synthetic control method is a very powerful method to be able to estimate average treatment effects on the treated and causal effects like that when we have quasi-experimental data, right? So how does the synthetic control method actually work? So what it does is it takes the pre-treatment data. So this is the data before the intervention. In this case, in our application, it's the lifting of the lifting of the shelter in place. And so what the synthetic control method is going to do is it's going to select a vector of weights W to minimize the distance between the dependent variable of the treatment unit and a weighted average of the control unit's dependent variables. So in our case, our application, the dependent variable would be daily COVID-19 cases. Our treatment would be Texas, and our control would be states that had a shelter-in-place order, but they didn't decide to lift it. A little bit of notation here, we're using T1 to denote the number of pre-treatment time periods, and we use T2 to denote the number of post-treatment time periods. And notice that this minimization problem is subject to 3 restrictions, and these 3 restrictions are that there's 0 intercept, the weights sum up to 1, and the weights are non-negative. So once we do this first step, we get the W hats, which are the estimated weights. We can basically do a plug-in to get the counterfactual, this Y hat not here. So this is basically what would the COVID-19 cases have been in Texas had we kept the shelter-in-place order instead of lifting it. So then once we have the counterfactual, we can subtract it from the actual data, which is the actual COVID-19 cases in Texas post-treatment, and average this over the number of post-treatment time periods, which is T2 here. And that's how we get the ATT, which is our causal effect of interest. And I just want to briefly mention here that this is for the synthetic control method, but we also look at the modified synthetic control method, which actually relaxes the second restriction that the weights sum up to 1, and also what we call the OLS method, which actually relaxes all 3 of these restrictions. So it's just running ordinary least squares to get the weights. Okay, so what are some challenges that come with developing the inference theory when we don't know, when we have non-stationary data of unknown structure? So the challenge here is that the control unit's outcome actually share this common non-stationary factor, which we're calling FT. This FT becomes the dominating factor, or sorry, the dominating component of all the regressors that we're using when we run a synthetic control. Therefore, all the regressors are essentially asymptotically collinear with each other. And this would not be such a hard problem to fix if we actually knew what the functional form is of this FT, right? So if we knew, for example, FT was a linear, it was just T, then we could basically just detrend it. If we knew that FT was a unit root process, we know how to deal with that. The real challenge comes with when we don't know the structure of this non-stationarity. So when an FT structure is unknown, then the standard ordinary least squares theory is going to break down. And so what we really need is to be able to develop the inference theory when the data are non-stationary of unknown structure. And that's exactly what we do. So this brings us to the inference theory, which is, again, the main contribution of this paper, where we develop the inference theory for quasi-experimental methods such as the synthetic control when we have data that are non-stationary, and in addition, we do not know the structure of that non-stationarity. So first, I would just like to talk about the non-stationarity of these weights, these W's, right? And then I'll talk about the inference theory of the ATT, which is what we're really interested in. So in the first theorem of the paper, we show that the ordinary least squared weights, or I'm kind of using coefficients and weights interchangeably, converges to a normal distribution. We show the rate of convergence of these weights, W hat, using the OLS method. We also show in the second bullet point, if we take a linear combination of these weights, it actually converges to a rate that's faster. And these weights over here multiplied by this unknown constant C matrix converges to a normal distribution. And so the interesting thing about this is that even though we don't know what C is and what omega is, we can still show through essentially normalizing and the central limit theorem that it's going to the normal distribution. And this is actually not super trivial to do because the hard thing is, we have all this collinearity, right? And so the key innovation, I'm not going to go through the math and the proofs, but the key innovation of being able to prove this theorem is that we use reparameterization. And once we reparameterize, that helps us get rid of the collinearity problem. That's a big deal. And because there's a one-to-one correspondence between the reparameterized model and the original model, we can back out essentially the distribution of the weights being normal. So we use this very important result to help us derive inference theory for the OLS average treatment effect on the treated estimator. And we find that it goes to a standard normal. And so once we know that, that allows us to calculate the confidence intervals. So that's very helpful for us. Okay, so now that we've done the OLS method, I'm going to move on to the inference theory for the synthetic control method, as well as the modified synthetic control method. And so this really relies on knowing that the distribution of the OLS weights goes to a normal distribution. That was our first theorem that we saw. And we also kind of use results in the Lee 2020 paper, which basically tells us that, this distribution of the synthetic control estimator is actually non-standard. It converges to two terms. The first term is actually a projection onto a tangent cone, essentially a convex set of the OLS distribution. And then the second term is going to kind of capture the error in the post-treatment. And so the key thing here is that, this distribution is not standard. It's not just a simple, normal distribution. So in this case, bootstrapping is actually going to break down for us, and we are actually going to have to use the subsampling method to help us create the confidence intervals. And so the subsampling method, I'm going to kind of go through the main steps, but you can essentially think of it as very similar in idea to a bootstrap, except when we take a sample, it's going to be smaller than the full sample size. Okay, so here are the main steps of the subsampling method. Essentially, we're going to draw the errors from this normal distribution. And then in the second step, we're going to take the last m time periods of the control units data, pre-treatment data. So once we have that, we can actually generate this y star here using the error in the first step and also the data in the second step. And then once we have that, we can actually estimate our synthetic control model or modified synthetic control model to compute this A star. And what I'm using for this A star here is essentially, if you go to the right-hand side of this equation over here, it's basically the subsample version of that. And so once I repeat these steps many, many times, I'm essentially able to get lots and lots of A star values. And I can order these A star values from smallest to largest and get the confidence intervals that way. For example, if I want the 95% confidence interval, I'll take the 2.5 to the 97.5 percentiles. So the key takeaway is that this subsampling procedure, compared with the parametric bootstrapping, helps us actually calculate these confidence intervals. And we can prove that this subsampling actually works theoretically as well. Okay, so what we've done so far, I just want to remind you what we've done so far. So far we've developed the inference theory for quasi-experimental methods such as the synthetic control method, as well as the modified synthetic control method and the OLS method, when we have data that are non-stationary of unknown structure, which is a very common setting we see in marketing as well as other disciplines. Now I want to show you through simulations that kind of back up our theoretical proofs. So the first thing I'm going to do is show you kind of our data generating process. We use this three-factor model here to create the outcomes. So here, YT, these would be, for example, in our example, the daily COVID-19 cases we see in both Texas and the control states. This B here is the factor loadings. And so I'm going to explore 4 different data generating processes here. Here I'm showing you the 4. And what you notice here is that for the first data generating process, the factor loadings are the same for the treatment and the control units. And so this is a case where there's a common distribution between your treatment and control. For the second and the fourth data generating process, this is a case where your treatment unit is pretty different from your control unit. It's actually a case where your treatment unit outcome is outside the convex hull of the control units. So in this case, we would expect probably the synthetic control method is not going to do as well, whereas maybe the modified synthetic control method might do better because it relaxes that restriction that the weights sum up to 1. And finally, this third data generating process is a case where the treatment unit is within the convex hull. So it's kind of more similar to that first data generating process. So let's compare the different methods that we're talking about in this paper, the synthetic control method, the modified synthetic control method, and the ordinary least squares method, and kind of just confirm that, the methods that we expect to do better in certain data generating processes indeed perform better. So first, on the left-hand side here, we're going to look at cases where your treatment unit is pretty similar to your control unit, right? So remember, in that first data generating process, this is the case where treatment units and control units are drawn from the same common distribution. And in the third data generating process, this is the case where your treatment unit is not identical to your control unit, but it's within the convex hull of the control units, meaning that synthetic control method would probably do well there. And so what you notice here is, as expected, the synthetic control method has the lowest mean squared error. And so it performs better when the treatment units and the control units are essentially pretty similar to each other. By contrast, if we consider the other two data generating processes, these are the cases where the treatment unit is more different than the control units. These are the cases where the treatment unit is actually outside the convex hull. We see that the synthetic control method doesn't do as well. And in fact, the modified synthetic control and the ordinary least squared is actually going to perform better there. Okay, so I'm just kind of showing you, in the paper, there's lots and lots more simulations for lots of different settings. Here are the columns, this 40-10, 80-10, this is just the T1, T2, so your pre and post treatment time periods. But I'm just showing you a few of them. There's a lot more simulation results in the paper. Okay, so now that we've shown that, the different data generating processes behave as expected, let me show you that we can actually recover the coverage probabilities, right? Because this paper is about inference and being able to calculate the confidence intervals. So here I'm showing you when we're using the ordinary least squares method, we're able to recover the coverage probabilities. Here, what you just want to notice is that for all 4 data generating processes, the coverage probability is very close to the nominal value, right? So for example, for 95% confidence interval for the first data generating process, our coverage probability is 0.9529. It's very close. So that's great. So let's do the same thing for the synthetic control method and the modified synthetic control method. So here, notice that for the synthetic control method, I'm just looking at the 2 data generating processes that where the synthetic control method should be used, which is the first and third one. And for the modified synthetic control method, I look at all 4. And what we notice here again is that the coverage probabilities for all data generating processes for these 2 methods is close to the nominal value. So in other words, we're able to recover the coverage probabilities. So even though we prove everything in the theoretical section of this paper, it's always nice to see in simulation that this also holds. Okay, the last simulation I want to show you is kind of an interesting simulation, and I think it's a pretty important simulation. So let me just take a little bit of time to explain what we're doing here. So if you remember back to the very first theorem that I showed you, which showed that the weights, converge to 0 at a rate of t1 to the -1/2, right? So how can we confirm this through simulation? So what we can do here is, if we know that that's the rate of convergence of the weights, the W's, then we know that the mean squared error should converge to 0 at the rate of 1/t1, okay? So what you notice here, if you look at the first column, if I multiply the t1 by the MSE, then essentially what should happen is if you compare the numbers across a given row, these numbers should be very similar to each other, okay? And so if you take a look at the last row, this is a linear combination. So here I expect, basically in simulations, you can actually create the FT. You can choose the FT, right? So in practice, we don't know what the structure of the FT is here. But in simulation, I can say, okay, I'm going to set this factor FT equal to T. And once I know that, I can use my theory to be able to tell what the rate of the mean squared error convergence should be. So essentially what you see here is that, when you look at this last row and all these numbers are essentially very close to 18, this basically backs up our theoretical proof of the first theorem, which is a key theoretical result in this paper. So I think, this simulation is kind of pretty cool. Okay, so that brings us to the empirical application, which Venki talked about at the top of this session, which is we're really interested in, what is the effect of lifting some of these shelter-in-place orders on COVID-19 cases? And so what we've done so far is, we've developed the inference theory for the synthetic control method and related methods when you have data that are non-stationary, but in addition, that structure of that non-stationarity is unknown. Okay, and we need this theory because, in a lot of cases, including our case here of looking at COVID-19 cases, the evolution of COVID-19 cases is going to be non-stationary. And, in practice, we don't know what the structure of that non-stationarity is. So we've developed the inference theory. We've kind of proved it. In the paper, I don't go through the proofs here, and I use simulations to kind of verify these the theoretical proofs. And so now that we have this inference theory, we're able to actually, tackle this empirical application. Here's the empirical setting. I just want to remind you, we're looking at data, daily state level panel data for COVID-19 cases. We're looking at the time period of March 1st to June 30th of 2020, and we get our data from Johns Hopkins University. And we focus on Texas because it's actually one of the earliest states to reopen. Texas reopened its economy in May 1st of 2020. So that's when Texas lifted its shelter in place. We use 8 states as control states, and these 8 states all issued statewide orders of shelter in place, but they did not reopen during the time period that we examined. So here I'm using the 3 different methods that we talked about in this paper, the synthetic control method, the modified synthetic control method, and the ordinary least squared method to calculate the ATT, right? And so here we see that there's about a 38% increase in COVID-19 cases as a result of Texas lifting its shelter-in-place order. And the actual ATT is daily cases. So we basically see that daily cases in Texas goes up by about 20,000 after lifting its shelter-in-place. So this is kind of a pretty dramatic effect, and let's see it visualized. So here, if we look at this plot here, on the x-axis is the days, on the y-axis is the number of cases. So this is daily COVID-19 cases. Notice that the dashed line here is the control, and the solid line is the treatment. So the solid line represents the actual COVID-19 cases that we observe in Texas. And this dotted line, after day 61, essentially, is the counterfactual. So this is what would the COVID-19 cases have been in Texas had we decided to keep that shelter-in-place order instead of lifting it. So what you can see here is that the difference between these 2 curves show that there's like a dramatic exponential, growth in the COVID-19 cases after Texas decides to lift its shelter-in-place order. And so, not only are we able to calculate the average treatment effect on the treated, in addition, we're able to calculate confidence intervals. So here I'm showing you just the confidence intervals for using the synthetic control method, using our subsampling bootstrap procedure. And so here we can see that the 95% confidence interval is between 14,000 and 27,000 daily cases. Okay. So, in conclusion, in many marketing applications, we have data that are non-stationary. And in practice, we don't actually know what the structure of that non-stationarity is, right? And so what we really need is to be able to develop inference theory when we're using for quasi-experimental methods, such as the synthetic control method, which has become very popular in marketing, to be able to estimate these causal effects of interest, such as the ATT, when the data are non-stationary of unknown structure. And so we do this using not only the synthetic control method, but also the modified synthetic control method, as well as the OLS method. And then we are able to calculate the confidence intervals around the ATT, not just the ATT itself. We theoretically derive the distribution of these ATT estimators, and we also show via simulations, that our theory basically works, and we're able to not only recover the coverage probabilities, but we're also able to confirm the rates of convergence for the MSE. And finally, we show through a very relevant example what is the effect of Texas lifting its shelter-in-place order on COVID-19 cases. We essentially see about a 38% increase in the daily COVID-19 cases as a result of Texas lifting its shelter-in-place order, which is a pretty big number. And we also show that it's statistically significant because we're able to calculate the confidence intervals around the ATT. And so that's everything I have to say. Thank you so much for staying for the last session. We really appreciate it, and we appreciate any of your feedback. And I look forward to Sujin's discussion.
We still have time for questions if anybody has any questions.
Oh, yes. Yeah, finished a bit early.
I have a question, Kathleen, Venki. A very interesting topical, of course, given the times we're in. But I was curious, you used COVID cases rather than deaths as your DV. Might be interesting to see, cases went up, but how badly were the number of daily deaths affected? Did you guys look at that at all or planning to?
We have not looked at that, but that's a really great suggestion. I think the only thing that might be a problem is if you don't have enough pre-treatment, because there's a lag time between getting COVID and actually passing away from COVID. And so I think that's a really interesting suggestion. We could definitely, I think that data is available publicly. So we could look to see, is scarcity not an issue? And if it's not an issue, then we could definitely run that analysis.
Yeah, the thought behind that is just the overall impact. Texas could justify that the cases went up, but deaths were not that different, or if the deaths are even worse percentage-wise, then the policies, negative side could be highlighted even more. So it seems like that might be helpful to highlight the impact.
Yeah, awesome. Thanks, Arun. Oh, Venki, you're muted right now. Venki, you're still muted.
Okay. Okay, I've been able to unmute myself. Thanks, Arun. As Kathy said, that was our challenge because we remember we had data from May 1 to June, end of June, but the pre-death data were very small. So the number of T1s that we had. And then, then we need to find another event, not in Texas, maybe some other event, to be able to really use that as a very strong deep outcome variable. So we're still looking at the data, but we could do that for another state.
So we're happy to take any questions now, or Sujin, you can take the discussion.
Can I start, Nanda?
Yeah, go on.
Okay.
Start. The reason I was trying to, have a discussion is because the other session started a little late, and we had I don't know when they're going to finish.
Okay, we can have a picnic, Nanda, so don't worry.
All right, Sanjan, go on. Carry on.
Yeah. Can you see the screen? Okay.
Yeah.
So hello, everyone. Aloha. My name is Sungjin Kim, and I'm an assistant professor of marketing at the University of Hawaii. And it is my honor to discuss Katie and Venki's really interesting paper. So let me start with what is the motivation of synthetic control method using an example. In 2010, Washington State started to levy a soda tax. And let's say we want to know what is the causal effect of soda tax policy on Washington soda sales. A popular method in this context is difference in difference method. To implement this method, we need to find a single control unit that follows the parallel trends with treated unit before treatment was implemented. So for example, if you look at the left panel here, the red line indicates Washington soda sales, which are affected by soda tax policy. And the blue line here indicates Oregon soda sales, which are not affected by soda tax policy. And to make a causal inference, we need to assume that Washington soda sales and Oregon soda sales would have followed the parallel trends if there was no soda tax policy in Washington. And this method works well if we can find a control unit that indeed satisfied with the parallel trends assumption. The synthetic control method says that, well, we usually have a bunch of control units. Why do we rely on a single control unit that needs a strong assumption like parallel trends? Can we use multiple control units to make the closest twin of the treated unit in a data-driven way? The synthetic control method is a generalization of difference in difference method in that it does not rely on parallel trends assumption. And by making a weighted average of control units, it provides a data-driven way of forming a counterfactual control unit. So if you look at the right panel here, the red line is again actual Washington soda sales, and the blue line indicates the synthetic Washington soda sales that are estimated by synthetic control method. And as we can see, the blue line and the red line follows almost same trajectory before soda tax, but they started to deviate when the soda tax was implemented. So the difference between this blue line, the synthetic Washington, and the red line, the actual Washington, is the causal effect estimate of the soda tax policy using the synthetic control method. Although synthetic control method is a powerful tool to make a causal inference, previous literature has identified at least 3 limitations of the standard SEM. These are restrictive constraints on parameter space, such as no intercept, non-negativity, and sum to 1, and lack of formal inference theory, which is essential to understand whether the treatment effect is significant or not, and large p small n problem, which happens when the number of control units is greater than the number of pre-treatment periods. The main contribution of this paper lies in dealing with the second and perhaps the most important limitation in the synthetic control literature, providing a formal inference theory. And especially this Lee 2020 JASA paper was written by presenter Katie. And I think this paper is very nice extension of Lee 2020. Now, let me briefly introduce extant models and then explain how this paper is different from extant models. Suppose we observe unit 1 through unit n, and unit 1 is the only treated unit. And you can think of it as Texas, which is affected by reopening the state during the COVID-19 pandemic. And unit 2 through unit n are control units, such as states that did not reopen the state. And we observe T periods, and T0 indicates when the treatment was happened. And let Y1 be outcome of unit J with treatment, such as COVID-19 cases after reopening the state, and Y0 be the outcome of unit J without treatment, such as COVID-19 cases without reopening the state. Notice that on the treatment, outcome on the treatment is observed, but outcome on the no treatment is not observed, such as Texas without reopening the state. And the treatment effect is the difference between this observed value and this unobserved value. So that means we can never observe treatment effect using observational data. But if we can somehow estimate this unobserved value and plug in this estimate to replace this unobserved value, then we can calculate the treatment effect estimate. So the problem boils down to how to accurately estimate this outcome on the no treatment, and how can we accurately estimate the statistical inference of it. To estimate this unobserved value, the synthetic control method imposes the similarity between the outcome of treated unit and the weighted average of outcome of control unit in the pre-treatment period. To estimate this weight, the standard SEM panel data method, or in this paper, it calls HCW method or OLS method, and regularized regression methods have been proposed in the literature. I think Katie already explained the main model in this paper, so I think I don't have to repeat it. But I would like to highlight that most previous studies implicitly assumed stationary data settings, and so the contribution of this paper is very clear. The proposed model in this paper explicitly allows the outcome variables to exhibit non-stationarity and non-linearity of unknown form. And as far as I know, no paper attempts to provide inference theory in this setting. And in that sense, I think this paper is a very nice extension of Lee 2020 JASA paper. And to construct a synthetic control, it uses a standard linear formation. Specifically, it considers 3 specifications: original synthetic control, modified synthetic control, and HCW method. And throughout the paper, the authors provide rigorous inference theory. And if we remember it, each y is non-linear and non-stationary of unknown form. And so it is very hard task to make an inference of this unknown form. And in a nutshell, the authors proposed inference theory based on a subsampling bootstrap procedure similar to Lee 2020. And finally, the authors applied a proposed method to examine how lifting a statewide shelter-in-place order affects the number of COVID-19 cases. The paper has very clear contribution and is tackling a fundamental problem of synthetic control methods. However, I have some suggestions to potentially improve the paper. The paper uses a very similar simulation scheme to Lee 2020. And simulation studies basically show that the subsampling bootstrap procedure works well in this setting. However, I wish I could see empirical improvement between this paper and Lee 2020 in terms of predictive accuracy, because these two papers uses very similar simulation scheme. As authors hypothesized in the paper, a misspecified non-stationarity structure may severely bias the ATT and invalidate inference, and I agree with that. But to test this, the authors may want to compare the simulation results of this paper to those Lee 2020 paper, which may be misspecified in this context. And if the authors can show better predictive accuracy compared to Lee 2020, I think it will enhance the paper's contribution. The second suggestion is why inference for only ATT. The paper focuses on proposing an inference theory on average treatment effect on the treated unit. However, we often want to know statistical inference for every time period. For example, if you look at the figure in this paper, it shows that right after the reopening, the increase in COVID-19 cases may not be significant, but in the long run, the effect of reopening may be significant. Researchers may want to know when does it become significant. And if we only have ATT in the post-treatment period, then in some sense, I think we aggregate the statistical inference as well. And in the synthetic control literature, some methods such as Broderson et al. 2015, Su 2017, Kim et al. 2020 provide statistical inference for every post-treatment period. So I would like to ask, can the authors provide inference theory for every post-treatment period? So that's my second suggestion. And third suggestion is related to the empirical application. The paper used 8 states that did not reopen the state to make synthetic taxes. However, I would argue that increased COVID-19 can be due to increased testing. And to be valid control unit, the control state should have similar positive rate with taxes. Also, as we can see in the figure again, the COVID-19 case in the pre-treatment period looks quite linear. And authors may need to demonstrate why this application is relevant to test non-linearity and non-stationarity of unknown structure in this setting. The first suggestion is related to definition of MSC, the modified synthetic control method. The authors defined modified synthetic control proposed by Duncan and Imbens 2016 as follows. The MSD method removes the first two constraints, no intercept and weight sum to 1, and only keeps the non-negativity weight restriction. However, Duncan and Imbens encouraged to relax all three constraints. Specifically, in Duncan and Imbens, it says that allowing for negative weight may well improve the out-of-sample prediction. And as far as I understand, the gist of Duncan and Imbens is to use an elastic net and relax all three SD constraints. And I think Lee 2020 made it very clear about how she defined MSD. So perhaps a better term will be MSD as defined in Lee 2020. So these are my suggestions that I would like to mention. Any questions?
Okay, thanks. This is wonderful for you to go through this and offer your suggestions. Kathy, we may want to talk a little bit about the definition, the labeling issue. We can take care of it. I'm sure that is it. But you had made a point. If you could go back to the previous suggestion, Sanjin. Yeah, the first bullet you had increased COVID-19 case can be due to increased testing. So I think what the synthetic control method and also the inference theory allows us that regardless of what, you can increase testing over time, so long as the controls, all the states, both the treated states and the control states do not vary dramatically their testing rates or policies, then it should be okay. And we make that assumption that it's random. And we mentioned control states should have similar positive rates. Well, I think they don't, I don't know what you mean by similar positive rates. They don't have to be the same level. That's really the advantage, as you rightly said in the earlier slides. The advantage of the synthetic control method is regardless of what levels these different control states have, the synthetic control method allows us to take the weighted average and do this. Unless you're saying the rate at which the positivity is increasing or decreasing, it should be similar. I don't know if that's what you meant, but per se, if they don't have to be the same level in terms of positivity rates. That's my reaction to that. Kathy, what about?
Yeah, I think that's a good point, right? Yeah, so if, one of the states, all of a sudden they increase their testing by a lot, that could potentially break. So I think it's a great suggestion to maybe check to see what we can find as far as how testing evolved over this time period that we look at. So yeah, thank you so much for all the comments and suggestions.
Do you guys have data on the testing? How many?
We don't, but maybe we can try to find it or.
As far to the best of my knowledge, I think neither the CDC nor the Johns Hopkins nor the WHO have that kind of data. And we know that what happened in the New York case when states are not reporting the accurately, so we can't even rely on the testing rates.
Venki, do you have any kind of data more granular on geographic level, or like county by county or city by city, or anything that you're more granular, like maybe hospitalization rates or severe cases? They talked about death. Anything that somebody could follow up on with additional analysis?
Yeah, to my knowledge, again, these statistics are available on a state-by-state basis. Some states have given more extensive information. Some states don't give. This is by city, county by county date. And the death rate is available, but as I said before, previously, we could not use it for the Texas case because our T1 is limited. And because of the lagging lag between case incidence and the mortality, it's kind of tricky to use that for interpretations. But we could try and see if you have some suggestions for any database that could have more reliable statistics on that, we'll be happy to look at them.
Sure, I'll follow up.
Thank you.
Any other comments or suggestions? We really very much appreciate and value this, even as we are revising this.
And did you say you had positivity rate information or no?
No, that would be dependent on the testing, right? So it's like a positivity is the ratio, right, of tested positive versus over how many tested, right? We don't have the number tested consistently across states, not to my knowledge.
Yeah, for the second suggestion is kind of interesting because as you probably saw in the paper, the average